Well, hello there, Night Owl. I do not know what your day looked like, whether it was a good one or the kind you would rather forget, but I'm glad it ended with you here under your blanket with a little bit of quiet finally settling in around you. So take a breath. Let your shoulders drop away from your ears just a little. Tonight we're going somewhere strange and cold and very far away, and I could not be happier to have the company. Here is where we are headed. Somewhere inside your body right now there is a small chance you are carrying a piece of another kind of human. Not a distant relative, not a metaphor, an actual different branch of the human family. One that vanished so completely, so quietly, that for most of history we never even knew it had existed. We only found out because of a single bone, a bone smaller than a pea, pulled almost by accident out of the frozen dirt of a cave in the middle of nowhere. Tonight, I want to take you into that cave on the exact day it happened. But first one small thing, and then I promise we will go. If stories like this one are your kind of comfort, the strange, the ancient, the quietly beautiful, it would mean a great deal if you tapped that like button before you get too sleepy to remember. It truly helps a small story like this one find its way to other night owls out there scattered across time zones, all looking for the same kind of quiet. And if you are new here, consider staying a while. Subscribing costs nothing, and it lets me know I should keep digging up stories like this one for you. I also love looking through your comments in the morning with my coffee, so tell me down below. Where in the world are you tonight, and what time is it right now, wherever you happen to be tucked in? I look through every single one, I promise. Alright, lights down low, maybe a soft fan humming somewhere in the background or the quiet static of rain if that suits you better. Get comfortable because we're about to travel very far from your bedroom. Picture southern Siberia. Not the Siberia you have seen in old films, all grey prisons and endless snow. A different Siberia. The Altai Mountains tucked into the corner where Russia quietly touches Kazakhstan, China, and Mongolia almost like four fingers meeting in the frost. It is quiet here. It has always been quiet here. Dark pine forests roll across the hills in slow green waves. Somewhere below, the Anui River moves through the valley cold enough to ache your bones on contact. And halfway up a pale limestone cliff half hidden behind brush and stone sits an opening in the rock. Not large, not dramatic from the outside. But duck through that opening and the space above you opens up into something almost cathedral-like. Tall ceilings, soft northern light drifting in from the entrance. And if you turned around to look back the way you came, a view down across the whole valley that must have felt remarkable even to the very first person who ever stood there. Local herders once had a different name for this place. In the old Altai tongue they called it Ajutash, Bear Rock, because for a long time that is exactly what it seemed to be. A den, a shelter for animals and nothing more. Then sometime in the 1700s, a hermit made this place his home. Local legend gives him a name, Denis, a man who apparently wanted nothing more from the world than to be left alone with it, tucked away from villages and neighbours and noise content with just the mountain, a small fire and his own thoughts. The people nearby started calling the cave after him, Denisova, the Cave of Deni. That old hermit could not possibly have known, sitting quietly by his fire praying or thinking, or simply listening to the cold air move across the rock, that scientists on the far side of the planet would one day speak his adopted home's name with something close to reverence, that his lonely little shelter would end up rewriting an entire chapter of human history. But we are getting a little ahead of ourselves. Let's step back much further first. Long before Denis. Long before herders and their sheep ever wandered past this cliff. This cave had already been quietly hosting visitors for close to 300,000 years. 3 connected chambers tucked into the rock, roughly the footprint of a modest 4-bedroom house. each one slightly different in shape in light and temperature. Different groups of people pass through here generation after generation, century, folding quietly into century, leaving behind ashes, broken tools, gnawed animal bones, and without any of them ever knowing it, tiny scattered fragments of their own bodies. Over the years, this same cave floor would also give up the remains of more than 60 different kinds of ancient mammals and dozens of species of birds. The leftover debris of thousands of perfectly ordinary days stacked quietly on top of each other for longer than the human mind is really built to picture. And here is a small, strange gift the mountain gave them without meaning to. The inside of this cave sits at a temperature just barely above freezing all year every year, and has for longer than anyone can properly imagine. That kind of cold is not comfortable. It is not kind to a body trying to stay warm through winter, but it turned out to be extraordinarily kind to everything left behind afterward, holding it all in a kind of frozen stillness, almost like the mountain itself was quietly saving its secrets for later. For most of the 20th century, nobody understood what was really sitting in that dirt. Not yet. Now let's fast forward, all the way to the summer of 2008. Every year around this time, once the mountain snow finally lets go of the valley, a small camp forms near the mouth of the cave, close to that same cold, clear river rushing by below. Canvas tents, a cooking fire, a handful of researchers, students and volunteers who trade away the comfort of a normal summer for weeks of dust mosquitoes and long patient hours spent underground. By day, the sun up here can almost feel generous. By night, the temperature drops fast enough to make you grateful for a second blanket even in the middle of July. It is not by any stretch a glamorous life. But there is something oddly peaceful about it too. The kind of quiet, repetitive work that lets your mind wander, even while your hands stay perfectly busy. By this point, archaeologists had already been carefully working this site for decades, under the direction of two Russian researchers, Anatoly Derevyanko and Mikhail Shunkov, from the Institute of Archaeology and Ethnography in the city of Novosibirsk. Layer by careful layer, their teams had been peeling back time itself, the way you might slowly open the pages of a book nobody had touched in 100,000 years. I want you to picture what this job actually looks like, because it is nothing like the movies. There is no cracking whip, no clever one-liner, no golden idol waiting on a stone pedestal lit dramatically from below. It is kneeling on cold stone for hours at a stretch. It is brushing dirt away one small section at a time, with the same patience you might use dusting your grandmother's china. It is sifting soil through fine screens again and again, staring at thousands of tiny fragments. Most of them nothing more than the bones of ancient rodents, birds, or animals that vanished from these mountains long ago. A bison tooth here, a fragment of horse jaw there. Hour after hour, mostly forgettable, mostly ordinary. Most days out there and quietly with sore knees, cold fingers and very little to show for it. Inside the cave that particular afternoon light came only from a handful of battery lamps catching dust in the air like slow-moving snow. The scrape of trowels against stone, somebody humming quietly to themselves the way people do when a job runs on, long enough to stop feeling like labour and start feeling almost like meditation. And then in a section of the cave known as the East Gallery, in a layer the archaeologists had carefully labelled 11 somebody's fingers closed around something small. It did not look like much, barely the size of a pea. Pale and slightly translucent, easy to mistake for just another chip of animal bone tossed into a bucket already full of them. If you or I had been kneeling there that afternoon, we probably would have flicked it aside without a second thought, and gone right back to the screen looking for something more obviously interesting. But the people working that site had learned through years of patient, unglamorous practice never to trust their eyes alone. They had learned to bag almost everything, label it, number it, Let someone with better tools and sharper instruments make the final call later back in a proper laboratory far from the mud and the cold. So that little fragment, smaller than your smallest fingernail, got tucked into a small paper bag, given a quiet number, and packed away with hundreds of other unremarkable-looking pieces from that season's dig. Nobody standing in that cave that afternoon had any idea what they were holding. Here is the part I find almost funny in a quiet sort of way. If you had laid out 100 fragments from that same layer side by side, this one would not have stood out at all. It looked ordinary, forgettable. Honestly, it looked like nothing. And yet, that single easy-to-overlook chip of bone was about to do something no dinosaur skeleton, no buried temple, and no chest of golden treasure had ever managed to pull off. It was about to force every single one of us to rewrite the story of what it means to be human. Not right away, though. Science rarely moves that fast, no matter how much we might want it to. The little bone sat quietly for a while, packed among that season's finds, waiting its turn along with dozens of others just like it. Eventually it was chosen, along with a small handful of other promising fragments, to travel somewhere far better equipped than a mountainside dig site. Wrapped carefully, cushioned against the cold and the miles ahead, sealed inside a small labelled container, it was shipped nearly 3,000 miles west across 2 continents to a research laboratory in the city of Leipzig, Germany. It made that trip the ordinary way most scientific specimens do, by truck along bumpy mountain roads, then by plane, then through the hands of several different couriers along the way, each one careful, each one professional, and not one of them aware they were quietly delivering what might be the single most important package of the entire decade. Most of the fragments making that same long trip that year would turn out to be exactly what they looked like. Old bone. Interesting perhaps to someone studying ancient animal life. Nothing more than that. This one would not be. At the laboratory, waiting on the other end, the Max Planck Institute for Evolutionary Anthropology, a team of scientists had spent years quietly learning how to coax secrets out of bones that were tens of thousands of years old. Bones so fragile, so worn down by time that most of their original material had already crumbled into dust and silence, leaving almost nothing behind to study. Almost nothing. I think about that little bone more than I probably should, if I am being honest with you. It travelled from a dark, freezing cave in the middle of nowhere, carried by hands that had absolutely no idea what they were really holding, all the way to a bright, sterile laboratory on the other side of the world. A journey no longer in distance than a coin sliding across a table. And yet it was about to rearrange how every person alive today understands their own family tree. Somewhere inside a small evidence bag, quiet and unassuming, sat a fragment of a child's pinky finger, about to answer a question nobody had even known to ask. Who else besides us once called this world home? And in that laboratory in Leipzig, the answer was already sitting quietly in the dark, waiting for someone to finally switch on the light. Stay right here with me, because what happens next inside that laboratory is the kind of moment most scientists only dream about once in an entire career. To understand what happened next, we actually have to step away from Siberia completely just for a moment. Not forward in time, backward, all the way to a university in Sweden more than 2 decades before that little bone ever left the mountains. There was a graduate student there working late alone in a lab he was not technically supposed to be using for this particular project. His actual research was on something else entirely, something to do with the immune system, the kind of respectable, fundable science a supervisor expects from a doctoral student. But at night, once the building had emptied out and the hallway lights had gone quiet, he would switch projects in secret. He had talked his way into getting soft tissue samples from Egyptian mummies, some of them more than 2,000 years old, kept behind the doors of a museum that trusted him more than perhaps it should have. And there alone under fluorescent light he was attempting something almost nobody believed was possible. He was trying to find deoxyribonucleic acid still surviving inside them. Imagine that scene for a moment. A young man alone in a borrowed room, the hallway outside completely silent, working carefully with tissue that was already thousands of years old by the time it reached his hands, terrified of ruining the only samples he'd been trusted with. There's a particular kind of nervous energy that comes from doing something you suspect might actually work, and being almost certain nobody would believe you even if it did. If that sounds unremarkable to you now, sit with how strange it would have sounded back then. This was the early 1980s. The idea that genetic material, the fragile molecule that carries the instructions for building a living body, could survive intact for thousands of years inside dried human tissue struck most working scientists as somewhere between wildly optimistic and faintly ridiculous. And yet working nights and weekends, half convinced his own advisor would be furious if he ever found out this student pulled it off, or at least he believed he had. In 1985, he published his results in the journal Nature under his name alone, describing what appeared to be genetic material recovered from a mummified Egyptian child. It made him something of a minor celebrity in scientific circles, almost overnight a young unknown, suddenly getting invitations from famous laboratories on the other side of the world. His name was Svante Pääbo, and here is the part of the story he does not shy away from telling even now, decades later, even with a Nobel Prize sitting on his shelf. He was wrong, not completely wrong. He really had found genetic material in those samples, but as he kept working, kept refining his methods, kept learning just how easily a single fleck of modern skin can drift into an ancient sample and quietly ruin everything, he arrived at a humbling conclusion. Much of what he had pulled from those mummies was not 2,000-year-old Egyptian genetic material at all. It was contamination, traces of his own cells or someone else's from careless handling, from breathing, too near the open sample from lab equipment that had touched other far more modern things only hours earlier. To be fair to him, he was hardly alone in this particular trap. Through the 1980s and into the 90s, the entire young field of ancient genetics went through something of a reckoning. There were bold headline-grabbing claims during those years about genetic material pulled from insects trapped in amber for millions of years, and even briefly from dinosaur bone. Almost all of it, once other laboratories tried to check, the work quietly fell apart under closer scrutiny. It turned out that recovering a clean, reliable genetic signal from something ancient was far harder than anyone in that first excited wave had assumed, and far easier to get wrong without ever realizing it. The tools were new, the excitement was real, but the safeguards, the boring, unglamorous checks that keep a laboratory honest had simply not caught up yet. Picture that for a second. Imagine building your early reputation on a discovery only to realize with growing unease that you may have been fooling yourself the whole time, and that half your entire field was quietly making the very same mistake. Most people, understandably, would have changed research topics after something like that. Pääbo did not. Instead, he became almost obsessive about precision. He spent the better part of the next 20 years developing painfully strict laboratory procedures specifically designed to keep ancient samples from being contaminated by the modern world, pressing in on every side. Full protective suits, positive pressure, clean rooms, ultraviolet light sterilizing every surface between uses, entirely separate buildings for handling old material versus new. He turned his own early failure into the strictest rule book in the field, almost by force of will. I find that oddly comforting, if I am honest with you. One of the most important scientific minds of our generation built his entire career on the back of a mistake he was humble enough to admit to publicly more than once long after he could have simply let it fade quietly from memory. Have you ever had an early failure quietly turn into the exact skill that mattered most later on? I would love to hear about it in the comments once tonight's story has finished unspooling. Now, let's return to that little Siberian bone sitting inside its evidence bag, finally arriving at the laboratory, where Perbo now worked as director at the Max Planck Institute in Leipzig. By the year 2010, this laboratory was, without much exaggeration, one of the most careful places on the entire planet for handling exactly this kind of material. Researchers suited up in white, head to toe the way you might picture a hospital operating room rather than a university research building. Air pressure inside the cleanest rooms was kept slightly higher than the hallway outside, so, if any tiny gap ever opened, air would rush outward, keeping stray dust from drifting in. Every surface got wiped down and hit with ultraviolet light between uses over and over, day after day. It was in almost every sense the exact opposite of the cold, dusty cave this bone had come from, and the exact opposite of that anxious young graduate student's borrowed lab table decades earlier. Here is where I want to slow down for a second and explain something, because it matters for understanding what happens next, and I promise to keep it simple. Deoxyribonucleic acid comes packaged inside our cells in two very different forms. Most of it lives inside the nucleus, the control center of each cell, built from a mix of both parents, an enormous and detailed instruction manual for constructing an entire body from scratch. But there is a second, smaller kind tucked away inside tiny structures called mitochondria, and this kind passes down only through mothers generation after generation, almost unchanged, like a name quietly handed from mother to daughter again, century after century. Here is the useful part for scientists trying to work with old bone. Each cell only holds 1 or 2 copies of that enormous nuclear instruction manual, but it can hold hundreds, sometimes thousands of copies of that smaller maternal kind. So when a bone has spent tens of thousands of years slowly breaking down, the maternal thread is simply far more likely to have at least one surviving readable copy buried somewhere inside the wreckage. Think of it this way if it helps you picture it. The nuclear instruction manual is like a single one-of-a-kind family library handed down whole generation to generation. Lose it, and it is gone for good. The maternal thread, on the other hand, is more like a short letter photocopied 1,000 times over and tucked into every drawer of the house. Even if fire or flood destroys most of the copies, the odds are still good that one survives somewhere waiting to be found. So quite sensibly, that is where the team started, not with the whole library, with the letter. A researcher on Perbo's team named Johannes Krause led the effort to pull that maternal thread out of the Siberian bone, and by early 2010 they had a complete readable sequence sitting in front of them. They compared it against a large collection of sequences already on file. Modern humans from all across the world, several different Neanderthal individuals, every reasonable candidate anyone could think to check. It did not match a single one of them. Not modern humans, not Neanderthals either, which was frankly the far more startling result, since everyone had quietly assumed a fossil from Siberia would turn out to be one or the other, simply a strange regional variant of something already known. Instead, this sequence sat off on its own branch entirely, roughly twice as different from both groups as they were from each other. Some members of the team, only half joking around the lab, started calling the sample the X-woman, borrowing the old algebra habit of naming an unknown quantity X, since a maternal thread can only ever confirm you're dealing with a female line, not necessarily the sex of the actual individual it came from. They published this finding in Nature that spring, and it caused a real stir across the field, paired with a fair amount of appropriate caution. A single maternal thread, remember, only tells you about one branch of a family tree. It cannot tell you how a population actually lived, how closely it related to the rest of us, or whether it had left any trace at all in people living today. For that, the team needed the harder thing. The whole library, not just the letter. So they kept going. Over the following months, using techniques Pabo had spent literal decades refining. Ever since that humbling lesson with the Egyptian mummies, his team attempted something that would have sounded like pure fantasy to him, as that anxious young graduate student sneaking into a borrowed lab after dark. They set out to recover a usable draft of the complete nuclear instruction manual from a bone smaller than a coin, a bone that had been sitting in near-freezing dirt for tens of thousands of years. By December of that same year they had it, and what they found changed the shape of the entire story. This was not simply an unusual variant of Neanderthal. It was not an odd, isolated pocket of early modern humans either. It was something else altogether. A separate population sharing a common origin with Neanderthals far back in time, then branching off to follow its own long independent path afterward. Surviving, adapting, apparently thriving across a wide stretch of Asia for tens of thousands of years, almost entirely unnoticed by science until this exact moment. And there was one more detail buried in that data, one so unexpected that the researchers reportedly checked their own numbers twice before believing it. Traces of this population's genetic material were not confined to ancient Siberia at all. Small but very real fingerprints of it showed up in the genetic makeup of certain people living today thousands of miles away on islands scattered across the Pacific. We're going to come back to that thread later tonight because it deserves far more room than I can give it right now, and rushing it would not do it justice. For the moment, just let it sit quietly in the back of your mind while you listen. This vanished population had not simply disappeared without a trace folded neatly into the past and forgotten. Some small, quiet piece of them was still walking around in the 21st century, tucked inside the bodies of people who had absolutely no idea it was there, carried forward without ceremony through hundreds of generations. Does that not sit a little strangely with you, in a good way, right before sleep? Now a species needs a name, and this is where the story quietly folds back on itself in a way I find truly lovely, even after telling it more times than I can count. They named this newly recognized group of ancient humans after the place where that first small bone had been found, Denisovans, after the cave, after the river valley in the Altai Mountains, after, in a strange roundabout way, a lonely hermit named Denis who lived out his quiet days in that cliffside shelter, roughly 250 years earlier, with absolutely no idea his adopted name would eventually be attached to an entire lost branch of humanity. I want to pause on something here because I think it gets glossed over too quickly in most retellings of this story. Ask most people what it takes to discover a new type of ancient human, and they will probably picture a dramatic museum scene. A full skeleton laid out on black velvet, a skull staring back at the camera, maybe a documentary narrator with a very serious voice hovering somewhere in the background. That is not what happened here, not even a little bit. At the moment this species was formally recognized, there was no skull, no skeleton. Not even a single complete tooth had been properly linked to it yet. There was essentially a fragment of bone the size of a pea, and an enormous amount of careful patient chemistry performed by people who had spent years learning exactly how not to fool themselves. This was quite remarkably the first time in the history of science that an entire human population had been identified and named almost entirely through genetic evidence alone, with barely any physical remains to back it up. Some researchers found that thrilling. Others understandably found it a little uncomfortable, a reminder of exactly how easily this whole field could go wrong again if it was not handled with total discipline. Which, of course, is precisely the discipline a young, humbled graduate student had spent his entire career quietly building one clean room at a time, ever since a mummy taught him a lesson he never forgot. There is something almost poetic about that if you sit with it for more than a second. The mistake shaped the method saved the discovery, and the discovery gave an entire lost people their name back, borrowed from a hermit who only ever wanted to be left alone with his mountain. But naming something is only the very beginning of understanding it. And there is a piece of this story I've been holding back on purpose, because it belongs back inside that cave in the very dirt this bone came from. Because as it turns out, that tiny Siberian bone was never really alone in there, not remotely. And what else was waiting quietly in that darkness is going to change how you think about this cave entirely. Let's go back inside. Not for the bone this time, for everything that came before it and everything that came quietly after. Here is a way to picture what this cave really was before we get into the specifics. Imagine standing at that same dark opening in the cliff and somehow watching 200,000 years pass by in the space of a few minutes, the way an old film reel might blur past if you spun it far too fast, decades collapsing into seconds. Snow falling and melting 1,000 times over. Firelight flickering on and off like a heartbeat, appearing for a while, vanishing for centuries, then returning again. You would not see one steady population settling in raising children and staying put for 200,000 years straight, the way we tend to imagine ancient life when we picture it at all. That is not what the layers of dirt in this cave actually tell us. What they tell us is something far stranger, and honestly far more interesting. The earliest residents show up first, and they stay the longest by a wide margin. Deep in the lowest layers, stone tools appear that may go back as far as 300,000 years, and genetic material preserved in the dirt itself, not just locked inside bone, shows this same population returning again and again on and off for something like 150,000 years after that. These are the people who would eventually be named Denisovans, and by any reasonable measure, this cave was their home far more than it ever belonged to anyone else who passed through it. Then somewhere around 200,000 years ago, new visitors start showing up in the layers too, Neanderthals. But here is where it gets truly interesting, and where I think a lot of popular retellings of this story get a little bit lazy. Neanderthal evidence at this exact cave clusters heavily around a particular stretch of time roughly 120,000 years ago, during a notably warm, gentle period between ice ages. Denisovans, on the other hand, kept showing up through the brutal cold stretches too. The deep glacial winters that most other human populations in the region seem to have struggled with or abandoned entirely. Try to picture the difference for a moment. A warm interglacial summer in these mountains would have meant open meadows, herds of grazing animals moving through the valley, rivers running high and easy to fish. A full glacial winter here would have meant something else completely. Bitter gusts of cold air driving snow hard against that cliff face for months on end, the ground frozen too solid to dig entire weeks, where simply staying alive took every scrap of skill and cooperation a small group could manage. Whoever kept coming back to this cave through winters like that was not doing so casually. Put plainly, the Denisovans appear to have been the tougher, more consistent tenants of this particular address. The Neanderthals look more like fair weather guests dropping in when conditions were comfortable, and thinning out once the climate turned hostile again. I do not say that to diminish Neanderthals, by the way. They thrived across a huge stretch of Ice Age Europe and Western Asia for a very long time, facing conditions that were brutal in their own right elsewhere on the map. This particular cave in this particular mountain range simply does not appear to have been their toughest test. It looks more like a pleasant seasonal stop along a much longer journey. And at some point in the middle of all this coming and going, these two different kinds of humans were not just passing each other somewhere out in the dark. They were near enough for at least a little while to share a fire-share food, and as later genetic evidence would go on to prove in a way nobody quite expected, share a good deal more than that. There is a particular story buried in these layers about exactly how far that encounter really went, and it is honestly one of my favourite chapters in this whole saga. I am going to save it for a little later tonight because it deserves its own quiet moment, not a rushed mention squeezed in between other facts. For now, just sit with this. Two entirely different branches of the human family, each carrying its own separate history, stretching back hundreds of thousands of years, ended up sharing the exact same patch of stone floor, at least once, maybe more than once. Denisovans continued showing up in this cave long after the Neanderthal presence faded out, right through some of the coldest stretches of the entire Ice Age, before finally disappearing from the record here around 50,000 years ago. Nobody knows precisely why. Climate shifts, changing herds of prey animals, slow population decline, or some combination of all three spread out gradually over centuries rather than happening all at once. Extinction in real life rarely looks like a single dramatic event. It usually looks more like a long, quiet, fading, the kind that only becomes obvious once you are already looking back at it from tens of thousands of years away. But the story of this cave does not end there, because not long afterward something new shows up in the layers, and whoever left it behind was doing something rather more sophisticated than most people tend to picture when they hear the word caveman. Around 40,000 years ago, someone in this cave carved a bracelet out of a beautiful dark green stone called chlorite, polished it smooth and drilled a hole clean through it. Modern researchers who first examined the drilled hole assumed understandably that the tool marks had to belong to a much later, more advanced period of history. Drilling a clean, symmetrical hole through solid stone is not a 5-minute task. It likely meant a handheld tool spun rapidly, using a cord wound around a wooden shaft and drawn back and forth, the same basic mechanism people would later rely on to spark fire, through friction, grinding patiently through stone for what may have been hours at a stretch spread across more than one sitting. That is not the behaviour of a creature simply surviving. That is someone with enough spare time, enough security, and honestly enough taste to want something beautiful and be willing to work for it. Picture that scene for a second if you can. Firelight throwing shadows across the cave wall. Somebody sitting cross-legged on the cold stone floor, turning that same length of green rock over and over between patient hands, checking the hole's progress, blowing away fine dust, starting again. Not hurried, not desperate, just quietly, stubbornly committed to finishing something that had absolutely no practical purpose beyond looking beautiful on somebody's wrist. I like imagining that scene far more than I like imagining spears and mammoth hunts, if I am honest with you. It feels closer to something we would still recognise in ourselves today, a matching ring carved from marble turned upright beside it. Somewhere between 43,000 and 49,000 years ago, pendants made from pierced deer and elk teeth appear too, along with slender bone points, likely used for stitching clothing, together the earliest ornaments of their kind ever found anywhere in northern Eurasia. A delicate bone needle, roughly 50,000 years old, ranks among the oldest sewing needles ever discovered anywhere on the planet, fine enough that whoever carved it must have had both remarkably steady hands and remarkably sharp eyesight. And in one of the deeper galleries a tiny carved cave lion barely bigger than your thumb, shaped out of woolly mammoth ivory, its surface covered in careful rows of notched decoration, dated to somewhere around 45,000 years ago. Quite possibly the oldest animal figurine ever found anywhere in the world. You might reasonably be wondering how anyone could possibly put such precise numbers on objects this old. It is a fair question, and the honest answer involves two rather clever, rather different tricks. Organic material like a tooth pendant or a carved bone point still holds a faint decaying trace of a particular type of carbon, one that breaks down at a steady, predictable rate once a living thing dies. Measuring how much of it remains works almost like a very slow, very reliable hourglass. The surrounding sediment itself gets dated a different way entirely. By measuring the last moment, tiny grains of quartz buried in that dirt were exposed to actual sunlight, sometimes tens of thousands of years ago, before they were buried and shielded from light for good. Between those two methods checked against each other layer by layer, researchers can build a timeline this precise without needing a single written record, a single calendar, or a single date carved anywhere in stone. Whoever made these things was not fumbling around with crude gestures at art and craftsmanship. They were planning ahead, selecting specific materials for specific purposes, practicing a skill often enough to get remarkably good at it. That is not the caveman stereotype most of us grew up picturing, the grunting, hunched-over brute dragging a club through old cartoons and film. That picture, frankly, has needed retiring for a very long time. Here is the part I think is the real gift hidden inside this chapter of the story. The twist most casual retellings tend to skip right past. You would assume reasonably enough that this kind of careful symbolic craftsmanship must have come from modern humans like us, since this is exactly the sort of behaviour we associate with our own species elsewhere in the world around this same stretch of time. Except archaeologists have never actually found a confirmed piece of modern human bone or modern human genetic material anywhere inside this particular cave. Not one to this day. Researchers who led the detailed chronology work on this site, including Tom Hyam at Oxford, along with Katerina Duca, who has spent years carefully dating material from sites exactly like this one, have openly said this remains a real unresolved question, not just a rhetorical flourish for a documentary. Nobody actually knows for certain whether it was the last surviving Denisovans making that jewellery, adapting and innovating right up until the end of their time here, or whether modern humans had already quietly arrived in the region and simply left no bones behind for anyone to find. Isn't that a wonderful, slightly maddening thing to sit with right before falling asleep? An entire cave full of proof that somebody was capable of beauty, of patience, of decorating themselves for reasons that had nothing to do with pure survival. And we still cannot say with total confidence exactly who that somebody was. I've always found something quietly moving about that particular kind of not knowing. We like our history tidy. We like clear names attached to clear achievements, a plaque on a museum wall telling us precisely who to credit. This cave simply refuses to give us that comfort, and honestly, I think it is more honest for it. Here is a small question worth turning over in your mind for a moment before you drift any further towards sleep. If you had to guess purely on instinct, who do you think carved that little lion out of ivory? Sit with your answer for a second, then let it go completely, because the honest truth is that nobody currently knows for certain, and there is something almost peaceful about simply accepting that, rather than forcing a tidy answer where none exists yet. I think this is really why this cave deserves to be remembered by more than a single name, Adjutash Bear Rock to the herders who first noticed it, Denisova after a hermit who wanted nothing more than quiet solitude, and underneath both of those names something bigger and stranger still, a shared address for three entirely different branches of humanity, stretched out across an almost incomprehensible span of time, sometimes missing each other by tens of thousands of years, and sometimes it turns out not missing each other at all. I think a lot of us grow up picturing human evolution as something like a relay race. One species runs, its leg passes, the baton quietly exits the stage, and the next one takes over from a clean, empty starting line. This cave is proof that reality was messier than that, and honestly far more interesting. Three different kinds of humans overlapping crossing paths occasionally, more than crossing paths inside the exact same 3 chambers of stone, spread out across roughly 300,000 years. Less like a relay race, more like a single small train station with different travellers passing through at very different times, occasionally waiting on the same platform, together without ever fully realising what that quiet shared moment truly meant. The site still matters enough today that the Russian government formally protected it several years ago, listing it among the country's most valuable cultural heritage locations, the kind of legal status meant to guarantee that nobody quietly builds a road through it, or lets it crumble away from simple neglect. And even now, decades into the excavation, researchers deliberately leave certain sections of that cave floor completely untouched, sealed off, preserved. Not because there is nothing left to find there, but because they suspect future scientists working with tools that have not been invented yet will be able to pull far more truth out of that same dirt than anyone working today possibly can. There is something quietly humbling about that choice if you sit with it for a moment. An entire team of brilliant, dedicated researchers deciding on purpose to leave part of the puzzle unsolved, on purpose, trusting people who have not even been born yet to finish the job properly decades or perhaps a full century from now. It is a strange kind of patience, the sort most of us rarely practice in our own lives. Most of us want the answer today, the credit today, the neat conclusion before we go to bed tonight. This cave has been quietly teaching the opposite lesson to everyone who has ever worked inside it for nearly half a century now, and it does not appear to be finished teaching it yet. If a single cave could hold 3 separate branches of the human family tree, sometimes generations apart, sometimes near enough to share a fire, it raises an obvious question. I have been quietly circling around this entire time without answering directly. How exactly were these 3 groups related to each other? Not just in the loose poetic sense of distant cousins sharing a cave out of convenience, in the literal biological sense. And it turns out the actual answer is a great deal stranger and a great deal more tangled than a simple family tree with 3 clean, tidy branches would ever suggest. Here is the truth nobody tells you clearly enough in school. Family trees, the kind with neat little branches splitting off in tidy diagrams, are mostly a comfortable lie we tell ourselves, because reality is far too messy to draw on a chalkboard. The actual relationship between these 3 kinds of humans looks less like a tree, and a great deal more like a river delta. One wide, slow-moving body of water that splits into several channels, drifts apart for a long stretch, and then every so often quietly rejoins itself again before splitting off once more, carving new paths nobody could have predicted from where the water first began. Let me draw the outline of it for you slowly, because it truly does reward slowing down rather than rushing past it. Somewhere over 500,000 years ago, a single ancestral population, one that would eventually give rise to all 3 groups we've been talking about tonight, began pulling apart. One branch of that population stayed on the path that would, after an almost unimaginable stretch of time, quietly become people exactly like you and me. The other branch wandered off in a different direction entirely, and for a long while afterward that second branch stayed together as one connected population moving through landscapes neither you nor I would likely recognize today. Then roughly 400,000 years ago, give or take, that second branch split again. One half became the ancestors of the Neanderthals, the other half became the ancestors of the Denisovans. So Neanderthals and Denisovans are not simply 2 separate discoveries that happen to share a headline the way they often get lumped together in a single breathless article. They are closer to siblings who left the family home together, travelled side by side for roughly 200,000 years, and only later went their own separate ways, each developing their own habits, their own tools, their own particular strategy for surviving a cold, unpredictable world. Here is where the story gets a little unexpected and honestly a little humbling. For anyone who quietly assumes Neanderthals were always the bigger, more successful, more thoroughly documented cousin in this family. When researchers compared genetic material recovered from several different Denisovan individuals against genetic material from every Neanderthal ever properly sequenced, combined together, the Denisovans showed more variation among themselves than the Neanderthals did as an entire group. Put simply, a small handful of Denisovan individuals looked more genetically different from each other than dozens of Neanderthals scattered across thousands of miles and tens of thousands of years. Try picturing it this way if it helps. Imagine walking into a small mountain village, one with maybe 100 residents, and finding that almost everyone shares a handful of family names, similar features, generations of intermarriage, within a tight, isolated community. Now imagine meeting just 3 strangers on a busy city street and discovering those 3 people are, genetically speaking, more different from one another than the entire village put together. That second scenario is roughly what scientists are describing when they talk about Denisovan diversity compared to Neanderthal diversity. A population spread wide enough, separated by enough distance and time, that even a tiny handful of individuals ended up looking remarkably unlike each other. What does that actually suggest? A population that was not small, not isolated, not clinging to bare survival in one tight little pocket of Siberia. It suggests something spread out, something with room to wander, to separate into distinct communities, to drift apart geographically for so long that their genetic material quietly recorded all of that distance and time within it. Neanderthals, for all their fame in documentaries and museum dioramas, may actually have been the smaller, more tightly knit family here. Denisovans, the population most people have still never even heard of, might have been the ones who were quietly everywhere. I find that a little bit funny, honestly. Neanderthals got the movies, the cartoons, the household name recognition, the go-to punchline for anyone joking about primitive ancestors. Denisovans got for the longest time a single finger bone and a great deal of academic silence. And yet the harder evidence increasingly suggests the quiet cousin was in some very real sense the more widespread, more successful one. It reminds me a little of how history tends to remember the loud sibling and quietly forgets the one who simply got on with things without ever making a scene about it. Fame, it turns out, is not the same thing as significance, whether we're talking about ancient hominins or about people you actually know in your own life. Somewhere right now there is probably a quietly remarkable person in your circle of family or friends who has never once demanded the spotlight, and who most people around them still do not fully appreciate. Denisovans might be the ultimate version of that story stretched out across 200,000 years. Now let me bring you something that only recently reshuffled this entire picture even further, because I think you deserve to hear where this story actually stands right now, not some simplified version frozen in place from over a decade ago. Back in 2008, remember that original pinky bone belonged to a young woman who researchers now believe lived roughly 65,000 years ago. For more than a decade afterward, her genome was essentially the entire public face of what a Denisovan even was. One woman, one data point quietly standing in for an entire vanished population, an entire branch of humanity condensed down into a single voice, speaking for everyone who had ever belonged to it. Then quite recently, a team led by a researcher named Stefan Perenya, working out of the very same laboratory in Leipzig. We spent time inside earlier tonight, managed to reconstruct a second remarkably complete genome. This one came from a molar, a single tooth recovered from the very same cave in the Altai Mountains decades earlier, and stored quietly ever since among thousands of other unremarkable fragments in a museum drawer waiting for laboratory techniques sensitive enough to finally unlock what it had been holding onto this entire time. Nobody chose that tooth because it looked special. It simply happened to be one of the fortunate few that had survived 200,000 years underground, with enough of itself intact to still speak, if someone eventually developed the tools patient enough to listen. This individual, a man, had lived roughly 200,000 years ago, more than 3 times older than the woman whose pinky bone had defined the entire species for over a decade. Suddenly, scientists had 2 proper detailed genetic portraits of Denisovans separated from each other by well over 100,000 years. And comparing them directly revealed something nobody had fully appreciated before. I want to pause on this for a second because I think it says something important about how science actually works, something that rarely makes it into the tidy documentary version of these stories. A lot of us understandably assume that once a discovery gets published, it becomes settled, fact carved permanently into the record the way a name gets carved into stone. That is not really how any of this works. For well over a decade, the scientific understanding of what a Denisovan even was rested almost entirely on one individual, one genome, one voice, representing an entire vanished population. It was not wrong exactly. It was simply incomplete the way a single photograph can be entirely accurate and still fail to capture the whole room. Science rarely hands you a finished painting. More often, it hands you the current draft with the honest expectation that a better draft is probably still coming. Denisovans were never one single stable population quietly holding steady in these mountains for 200,000 years straight. There were at least 2 genetically distinct Denisovan communities that occupied this same cave at very different points in time, one eventually replacing the other. The older population, the one this newly discovered man belonged to, appears to have mixed with an early wave of Neanderthals passing through the region. Later after that, first community had vanished from the record for reasons still unclear. An entirely different Denisovan community moved into the same territory, arriving generations after the first group's story had already quietly ended, and this newer group had mixed with a separate later wave of Neanderthals instead. 2 different Denisovan populations never overlapping with each other, as far as anyone can currently tell. 2 separate rounds of mixing with 2 different Neanderthal groups, separated from each other by tens of thousands of years, all happening inside roughly the same few hundred square meters of stone, as though the cave itself simply kept hosting new tenants, long after it had forgotten the ones who came before. And then there is the detail that truly stopped me in my tracks the first time I came across it. This older 200,000-year-old man carried genetic material from something else entirely. A population even older, even more mysterious one that had already split off from the rest of the human family, before Denisovans and modern humans had even properly gone their own separate ways. Researchers have started calling this a super archaic lineage, mostly because nobody currently has a better name for it. We have never found a single bone, a single tooth, a single fragment belonging to this group. We know it existed at all only because it left a faint genetic echo behind tucked quietly inside the genome of a Denisovan man who lived 200,000 years ago, carrying secrets from a population that might otherwise have vanished from history entirely without leaving a single trace anywhere in the fossil record. It is little like discovering a handful of unfamiliar words scattered inside an old family letter, words that do not belong to any language your relatives ever spoke, no explanation attached, no other evidence. The people who once spoke that language ever existed at all. Just the words themselves quietly surviving, borrowed and passed down without anyone along the way fully understanding where they had originally come from. Sit with that one for a moment if you can right before sleep pulls you further under. An entire branch of the human family that we would know absolutely nothing about, not even that it once existed, if one particular Denisovan individual had not at some point deep in the past crossed paths with them, and quietly carried a small piece of that ancient meeting forward generation after generation until it finally reached a laboratory bench in Germany a few short years ago. Have you ever pulled at one loose thread in your own family history, only to discover an entire hidden branch nobody had ever mentioned? At the dinner table, I imagine most families have at least one secret like that tucked away somewhere, waiting for the right conversation to surface it. This cave, it turns out, had several layered one on top of another. Taken together, these two genomes now suggest that at least 3 genetically distinct Denisovan populations contributed to the genetic material we still find, scattered across people living today in very different corners of the world. It is not one tidy population handing down one uniform inheritance, the way a single grandparent might pass down one recognizable family trait to every grandchild equally. It is several separate populations, each making their own quiet contribution at different points in different places long before anyone involved could have had the faintest idea what any of it would eventually come to mean for people not yet born. Think about what that actually implies for a moment. 2 people alive today, both carrying traceable Denisovan ancestry, might be carrying echoes of entirely different Denisovan populations that themselves may never have met each other, separated by tens of thousands of years and enormous distances. They would share a label Denisovan ancestry, without necessarily sharing anything resembling the same actual ancestors. It is a bit like discovering that 2 strangers both happen to carry old family silverware, only to learn the silverware came from 2 completely unrelated households on opposite sides of the world, centuries apart, and simply ended up looking similar enough to be mistaken for the same inheritance. Exactly where those different populations lived and how far they actually travelled across the map turns out to be its own remarkable story, one I am going to save for a little later tonight because that particular journey is far bigger and far stranger than most people ever assume. There is one more small detail worth sitting with before we move forward tonight. Based on the genetic evidence gathered so far, researchers now believe Denisovans likely carried notably darker skin than Neanderthals, who by most genetic estimates were considerably paler, an adaptation many scientists associate with life at higher latitudes and lower sunlight over many thousands of generations. We're going to come back to the question of what Denisovans actually looked like a little later on tonight, because there is a wonderfully strange piece of that particular puzzle still waiting for us. For now, just let that small detail settle quietly in the back of your mind, alongside everything else we have gathered so far. So here is where that leaves us. Not a tidy family tree with 3 clean branches the way I imagine most of us pictured it before tonight. Something closer to a braided river, several currents splitting apart, drifting for tens of thousands of years, occasionally brushing against each other again, sometimes mixing, sometimes staying separate, all of it moving forward across an almost incomprehensible span of time toward the exact moment you happen to be lying in bed, listening to this sentence right now. And that brings us to something I have promised to save for later, more than once tonight, because it truly deserves its own quiet space, rather than a passing mention buried inside a wider explanation. All of this, the split ancestors, the separate populations, the mysterious super-archaic lineage, all of it is built from statistics, probabilities, careful mathematical inference stretched thin across hundreds of thousands of years. Useful, honest, hard-won knowledge built by patient people working with almost nothing, but still in the end inference. But there is one piece of evidence in this entire story that is not inference at all. Not a probability, not a percentage tucked away inside a research paper, footnoted and hedged with careful academic language. A single direct physical result of one particular meeting between 2 individuals preserved by pure accident for around 90,000 years, waiting quietly in the dirt of that same cave for someone to finally notice it and recognize exactly what it was. I think it is time we finally went and found her. 2012. Back inside that same cave in a season of digging that on the surface looked like almost every other season before it. The same cold stone, the same slow, patient scraping, the same buckets of sediment carried out and sifted one careful layer at a time the way it had been done for decades already, somewhere in a storage tray sitting quietly among more than 2,000 other bone fragments. Pulled from those same layers of dirt was a single sliver of bone barely bigger than your thumbnail. Not a tooth, not a finger, just a broken piece of what had once been someone's arm or possibly their leg, worn smooth by tens of thousands of years underground. If you had picked it up and turned it over in your palm, you almost certainly would have assumed it belonged to a deer or a horse, or one of the dozens of other animals whose bones filled that same cave floor. There was nothing about its shape, nothing visible to the naked eye that marked it out as anything special at all. For years it simply sat there in storage. One fragment among thousands waiting its turn the same quiet way that Pinky Bone once had decades earlier, before anyone understood what it truly was. Eventually, a researcher named Samantha Brown, working with Tom Hyam's team at Oxford, began going through those thousands of unidentified fragments using a technique that sounds almost like a magic trick the first time you hear it explained. Bone is mostly built from a protein called collagen, and it turns out collagen looks subtly different depending on which species it came from, different enough that a sufficiently sensitive instrument can tell a human bone apart from a bear bone or a wolf bone just by examining the protein's particular signature without needing a single visible clue. Brown ran fragment after fragment through this process, patiently sorting animal from human, hour after hour, tray after tray. And somewhere in that enormous pile, this particular sliver came back flagged as belonging to a hominin, a person. Not which kind of person yet, just unmistakably a person. That distinction person versus animal was only the first door. Behind it stood a much bigger question, one that would need an entirely different kind of science to answer properly. If you've been listening carefully tonight, you may have noticed something interesting happening beneath the surface of this whole story. Extracting genetic material from ancient bone, measuring the decay of radioactive carbon inside a pendant, reading the last flash of sunlight trapped inside grains of buried sand, and now identifying a species from the subtle shape of a single protein. 4 completely different branches of science developed decades apart by entirely different teams of researchers, all eventually converging on this one small cave in Siberia, each one adding another piece nobody else could have found alone. No single method could have told this whole story by itself. It took an entire quiet army of specialists, most of whom will never receive a fraction of the recognition they deserve, working for years without knowing exactly what they might eventually uncover. The fragment made its way to a young researcher named Vivian Slon working in Leipzig in the same laboratory we have spent so much time inside tonight already. Her job was to pull genetic material out of the bone and figure out once and for all exactly what kind of person this had been. What came back did not make sense to her at first. Not because the sample looked contaminated or degraded or unreadable, the kind of ordinary technical headache this laboratory had spent decades learning to guard against. It made sense almost too well in a way that felt more like an error than an actual discovery. The genetic material was not simply Neanderthal. It was not simply Denisovan either. It looked almost impossibly like both tangled together in roughly equal measure in a pattern that any experienced geneticist would recognize immediately if they let themselves believe what they were looking at. A pattern you only ever see in a child born to 2 parents from 2 truly different populations, Slon's first instinct, by her own account, was doubt. She assumed she'd made a mistake somewhere along the way, some technical error, some mix-up between samples sitting too near each other, on the same laboratory bench, the kind of small human slip that happens to even the most careful scientist eventually. So she went back and tested a completely different piece of the same bone, independently from scratch, half expecting the strange result to quietly disappear the second time around. The result came back exactly the same. Here is what that result actually meant, stated as plainly as I can manage. This particular young person had a Neanderthal parent on one side and a Denisovan parent on the other, not a distant ancestor 3 or 4 generations back the way most of us might discover an unexpected relative buried somewhere deep in a family tree during a quiet evening of curiosity. A parent, directly. One of the 2 people who had raised her, if she'd been raised by both walked beside her, possibly loved her, came from an entirely different branch of humanity than the other did. Comparing the X chromosome data against the rest of her genetic material confirmed she was a girl. And a careful look at the thickness of the bone itself suggested she had lived to be at least 13 years old before she died somewhere around 90,000 years ago inside or somewhere near the very cave where her broken bone would eventually be found all these thousands of centuries later. The team nicknamed her Denny, an easy, almost affectionate shorthand for Denisova 11, her official specimen number, the kind of small human gesture scientists sometimes allow themselves after months spent quietly getting to know someone who's been gone for 90,000 years. I want to sit with her for a moment, if that is all right with you, because I think the numbers alone do not quite capture what this discovery actually means. Picture a 13-year-old girl somewhere in the cold foothills of the Altai Mountains, 90,000 years before either of us existed. Her mother most likely looked different from her father, moved differently, perhaps spoke differently, carried different habits and different inherited memories passed down from 2 populations that had been quietly drifting apart from each other for hundreds of thousands of years before these 2 particular people ever crossed paths. And this girl carried both of those inheritances at once stitched together inside a single ordinary human body, the same unremarkable way any child carries pieces of both parents. We will never know her name, obviously. We will never know whether she felt fully at home among her mother's people, her father's people both, or neither. We do not know if she was seen as unusual by the people around her, or simply as someone's daughter, nothing more remarkable than that. History left us nothing but a fragment of bone and a genetic signature. But I think it is worth pausing on the fact that mixed heritage, blended families, children who belong to more than one world at once, none of that is some modern invention we stumbled into recently. It appears to be about as old as humanity itself, quietly written into the story from very near the beginning. I like to imagine gently and without any real proof to back it up that she probably did not think of herself as a scientific milestone the way we now treat her. She was likely just a girl, cold in winter, hungry sometimes, learning whatever skills the adults around her thought a 13-year-old needed to know in order to survive one more season. Whatever mattered most to her on an ordinary afternoon almost certainly had nothing to do with genetics or ancestry, and everything to do with the small immediate concerns of being a young person trying to grow up in a hard world. It is only from our distant vantage point 90,000 years later that her existence became remarkable at all. Have you ever felt like you belong to 2 different worlds at once, whether through family culture or simply the different competing sides of your own personality? I have a feeling more of you listening tonight will recognize that particular feeling than you might expect walking in. Denny, it turns out, may be the oldest known example of exactly that particular kind of belonging, or not quite belonging anywhere in the human story. Now here is where the story gets even stranger, because her family history did not stop at her two parents. When researchers looked closely at her mother's side of the family, they found something unexpected. Her Neanderthal mother's genetic material matched most closely, not with the older Neanderthals who had lived in this exact cave generations earlier, but with Neanderthals recovered from a site called Vindiga Cave in modern-day Croatia, thousands of miles to the west, which suggests her mother's ancestors, or perhaps her mother herself, within her own lifetime had travelled an extraordinary distance across the continent, part of a much larger, slower migration of Neanderthal populations moving east from Europe towards Siberia sometime after roughly 120,000 years ago. A journey that likely took many, many generations to complete on foot across some of the harshest, most unforgiving terrain on the entire planet mountain range after mountain range river after frozen river. And her father's side held its own quiet surprise. His genetic material carried traces of an earlier Neanderthal ancestor two further back in his own family line, entirely separate from Denny's mother's side of the story. Which means genetic mixing between Neanderthals and Denisovans did not happen just once in one chance meeting between Denny's parents. It had already happened at least once before, in an earlier generation somewhere further up her father's own family tree, long before he ever met the woman who would become Denny's mother. Two separate mixing events inside one girl's immediate ancestry alone. Here is the detail that for me quietly changes the entire meaning of this discovery. At the time, researchers found Denny scientists had only managed to recover usable genetic material from a small handful of individuals at this cave, somewhere around half a dozen in total from tens of thousands of years of occupation. And within that tiny sample, not one but two of them already showed clear evidence of mixing between Neanderthals and Denisovans. Think about the odds of that for a moment. If direct hybrids like Denny were some kind of rare once-in-a-million accident, the chances of stumbling across not one but two separate examples of mixing within such a small handful of recovered individuals would be almost absurdly unlikely, statistically speaking. It would be a little like randomly interviewing 6 strangers off the street for an unrelated survey, and discovering that 2 of them happen to have won a national lottery at some point in their lives. Technically possible. Practically almost impossible to believe unless something about your sample was not quite as random as you first assumed. One well-known researcher outside the study put it in a way I still think about, often comparing the situation to searching for a single needle in a haystack, and instead accidentally discovering the entire haystack was made of needles the whole time. When you go looking for one exceptionally rare thing, and instead trip over evidence that it might not be rare at all, it forces you to rethink the whole picture from the ground up. The far more likely explanation, the one most researchers now lean toward, is not that Denny was some extraordinary fluke or one-in-a-billion cosmic accident. It is that whenever Neanderthals and Denisovans happened to cross paths, mating between the two groups may have been common, maybe even fairly ordinary, rather than some rare exception worth a footnote. Not a scandalous accident whispered about around the fire. Simply what happened quietly again and again whenever 2 different branches of the same wide tangled human family found themselves sharing the same patch of ground for long enough to become something more than strangers. I find something strangely comforting in that idea, if I'm honest with you. We like to imagine the distant past as cold, separate, tribal, every group keeping strictly to itself out of fear or suspicion of anyone different. The actual genetic evidence tells a gentler story than that. When these different kinds of humans met again and again across hundreds of thousands of years and thousands of miles, they did not simply avoid each other or eye each other with permanent suspicion from opposite sides of the fire. They fell in together. They had children. They built, even if only briefly, something resembling a shared life. There is a version of this story where Denny is just a stray footnote, a genetic curiosity buried inside a research paper most people will never come across in their entire lives. I do not see her that way. I see her as proof that the boundaries we like to draw around who counts as one kind of person and who counts as another have always been far blurrier and far more human than the tidy categories in any textbook would ever suggest. We have spent tonight tracing where these two families came from, how they split apart, and how every so often they quietly found their way back to each other. But there is still one enormous question sitting unanswered underneath all of it. If Denisovans and Neanderthals really were crossing paths this often, this far apart from Siberia all the way to Croatia, then exactly how far did the Denisovans themselves actually travel on their own, away from this one small cave that has held our attention for so much of tonight? Because as it turns out, this cave, for all its importance, was never the whole story. It was simply the place where the story happened to get written down clearly enough for us to finally understand it. The Denisovans themselves did not stay put, and the rest of that map is going to take us somewhere far higher and far colder than anywhere we have travelled together tonight so far. All the way up, in fact, to the roof of the world itself. The roof of the world is not a figure of speech where we are headed next. It is closer to a literal description. The Tibetan Plateau sits more than 3,000 meters above sea level, an entire elevated country of thin, cold air where simply breathing normally takes noticeably more effort than it does almost anywhere else most of us will ever stand. Visitors who arrive from lower ground often describe the same strange sensation, a persistent shortness of breath during even the gentlest walk, a dull headache by evening, the sense that their own body has quietly become a stranger to itself for a few days until it slowly learns to adjust. Athletes train for months to compete at altitudes far lower than this. Entire mountaineering expeditions carry bottled oxygen simply to walk comfortably at heights. The people we're about to meet apparently called home, without any equipment at all, for longer than our species has had written language of any kind, and somewhere along the northeastern edge of that plateau, tucked into a pale limestone cliff face, very different from the dark Siberian forest we've spent most of tonight inside, there is another cave. This one has never needed a hermit to give it a name. Locals already called it Baishia, which translates roughly to white stone cliff, long before anyone thought to look inside it for anything other than a place to pray, because that is what this particular cave has quietly been for a very long time. Not an archaeological site, a sanctuary. Tibetan Buddhists have visited this cave for generations, believing it connected to the meditation of great spiritual teachers of the past, a place where the 10th Panchen Lama himself once came to pay respects back in 1982. People still climb up to it today, not with trowels and brushes, but with quiet reverence, the way you might visit any place your own tradition has taught you to consider sacred ground. In 1980, a monk was doing exactly that, praying or meditating somewhere inside that cave when something on the ground caught his attention. A piece of bone, half buried, oddly shaped nothing, like anything he would have expected to find in a place people came to for stillness rather than digging. Picture the moment for a second. Dim light filtering in from the cave mouth. The particular hush of a place built for quiet contemplation. And then this small, unexpected interruption. Something hard and pale pressed into the ground beneath years of undisturbed dust. He did not know what it was. There was no reason he should have. He picked it up anyway, carried it out with him, and eventually passed it along to a respected religious figure known as the living Buddha of Gungthang, the sixth person, to hold that particular title and lineage, and that religious leader, recognizing it as something worth preserving, even without understanding exactly what it was, donated the fragment to Lanzhou University, entrusting it to people whose job was to study such things properly. And then for a very long time, almost nothing happened. Here is a small confession about how science actually works that rarely makes it into the finished documentary. Sometimes the hardest part is not the discovery itself. It is figuring out what on earth you are even looking at and where it truly came from. The university held onto this jawbone fragment for years, unsure how to classify it. It clearly belonged to some kind of ancient human, or something closely related to one, but there was no way to properly study it without first knowing something crucial. Exactly which cave had it come from? And the monk all those years earlier, focused on prayer rather than paperwork, had never thought to write that detail down. Think about that for a moment. An entire mountain region riddled with caves tucked into cliffs and hillsides across a huge stretch of territory. A single fossil already separated from the ground that had held it for longer than any of us can properly imagine. And absolutely no record of precisely where among dozens of possible caves scattered across that landscape it had actually been resting. Eventually a geologist named Fahu Chen and his graduate student Zhang Dongju took up the challenge. It became something closer to detective work than traditional archaeology. They spent years surveying cave after cave across the region, comparing rock types, mineral crusts, and subtle geological clues against the fossil itself, slowly narrowing an enormous list of possibilities down to a short list, then down further still, cave by cave, season after season, most of those trips almost certainly ending in nothing more than a longer list of caves to rule out next. It took roughly 6 years of patient, unglamorous effort before they could finally say with real confidence that this particular jawbone had almost certainly come from Baixia Karst Cave. Knowing which cave, though, was only step one, because this was not an abandoned patch of wilderness where a research team could simply show up with shovels and start digging. This was and still is an active place of worship visited regularly by people who had absolutely no reason to welcome a team of strangers tearing into the floor of a space they considered holy. Getting permission to properly excavate inside a living Buddhist sanctuary took years of careful, respectful negotiation, the kind of patient diplomacy that never makes it into a headline, but without which none of the rest of this story could have happened at all. Formal excavation work did not properly begin until around 2016, decades after that monk first walked out of the cave holding a piece of bone he could not identify. I find something quite admirable about that patience, honestly, on both sides. A community protecting something they considered sacred. A team of scientists willing to wait years rather than push their way in and risk damaging trust that had taken generations to build. When researchers finally examined the fossil properly, they found a thin, hard crust of mineral deposit, clinging to part of it, the kind that slowly builds up on cave surfaces over immense stretches of time, layer upon microscopic layer, almost like the cave itself had been quietly wrapping the bone in a protective shell. By measuring the natural steady decay of uranium trapped inside that crust, they were able to establish a minimum age for the fossil underneath it, at least 160,000 years old. 160,000 years on the roof of the world, long before anyone had ever heard the word Denisovan, and long before anyone even suspected any kind of ancient human had successfully made a home at this altitude at all. But here the story runs into a genuine scientific problem, one worth pausing on for a moment. By this point in the fossil's incredibly long history, there was simply no usable genetic material left inside it to recover. None whatsoever. The conditions in this particular cave, combined with the sheer span of time involved, had broken it down completely. For a discovery built almost entirely on the strength of pulling genetic secrets out of old bone, that should have been the end of the story right there. A fascinating jawbone correctly dated, permanently unidentifiable. Except researchers had one more trick left to try a more advanced relative of the protein sorting technique we talked about earlier tonight, pushed a good deal further than simply telling human bone apart from animal bone. Genetic material breaks down relatively quickly, as it turns out, compared to certain proteins, which can survive intact for a great deal longer under the right conditions. A researcher named Frido Welker led the effort to extract and carefully analyze ancient protein sequences preserved inside the mandible's remaining dental tissue, essentially reading a coarser, sturdier kind of biological information that had managed to survive long after the more fragile genetic material had completely vanished from the bone. It is a bit like losing a detailed diary to water damage, the ink completely dissolved beyond recovery, but somehow finding the diary's leather cover still intact enough to identify exactly whose handwriting had once been pressed into it, just from the wear patterns and the initials stitched into the binding. The protein signature that came back was unmistakable, Denisovan, and this is the detail that truly reshaped the entire scientific picture. Every single Denisovan fossil found up to that point, every scrap of evidence gathered over the previous decade had come from one single cave, thousands of kilometers away, buried deep in the cold forests of Siberia. This jawbone proved for the first time that Denisovans, or a population closely related to them, had also been living on the exact opposite end of a truly enormous range, high on the Tibetan plateau, in conditions almost nothing like the ones back in that Altai cave we have spent so much of tonight exploring together. Cold, thin oxygen starved mountain air more than 3,000 meters above sea level is not a forgiving place for a human body to simply show up and casually survive in. And yet here was direct physical proof that some population of ancient humans had done exactly that more than 160,000 years ago, doing so successfully enough to leave descendants behind long before modern humans are known to have arrived anywhere near this particular stretch of mountains. I want you to sit with that geography for just a second, because I think it is easy to breeze past a number like 160,000 years without really letting the distance involved sink in properly. From the cold pine forests of southern Siberia to the thin, dry air of the Tibetan plateau is roughly the same kind of distance as crossing an entire continent through some of the most demanding terrain on the planet. Somehow, whether through slow migration over countless generations or independent adaptation happening in more than one place, at once this same lineage of humans had managed to make a home in both. Have you ever travelled somewhere far from home and felt that particular kind of dizziness at just how much distance your own body had covered in a single day, tucked inside a metal seat with a cup of coffee balanced on your tray table? Now imagine that same distance, except instead of a few hours in the air, it took countless generations entirely on foot, with absolutely no idea what lay beyond the next mountain range, or whether it held anything worth surviving for at all. There is more still. A few years after the jawbone itself was confirmed, a separate research team returned to that same cave and did something remarkable. Rather than searching only for bones or teeth, they carefully collected samples of the cave floor sediment itself, the ordinary-looking dirt that had been quietly accumulating for tens of thousands of years, and tested it directly for traces of ancient genetic material still clinging to the particles. They found it. Denisovan genetic material recovered from 4 separate layers of that sediment dated across a huge span of time somewhere between 45,000 and 100,000 years ago. That detail matters more than it might sound like at first. It means this was not some brief one-time visit by a single wandering group passing through once and never returning. Denisovans, or people closely tied to them, kept coming back to this exact spot across an almost unimaginable stretch of time, generation after generation, treating this same high, cold cave as a reliable, familiar home The same way families return again and again to a favourite place across their own much shorter lifetimes, I find something quietly moving about the fact that this fossil spent nearly 40 years passing through entirely human hands, a monk, a religious leader, a university archive, before anyone fully understood what they were actually holding. Long before any scientist confirmed its identity, someone had already decided purely on instinct that this strange piece of bone deserved to be kept safe rather than discarded. Sometimes the most important scientific evidence in the world survives not because of laboratories or funding, but because someone somewhere simply felt that a thing worth keeping should not be thrown away even without understanding why it mattered yet. Have you ever held on to something for years with no real explanation for why, only to discover much later exactly why it had always mattered? I suspect that quiet instinct, the one that tells you to keep something rather than let it go, is older and wiser than most of us give it credit for. Maybe it is worth trusting a little more often than we usually do. So here is where that leaves the map of this story so far. One population once known only from a single freezing cave in Siberia, now confirmed to have also thrived on the opposite side of an entire continent in one of the most punishing environments on the planet for a human body to endure. Two locations thousands of kilometers apart, separated by mountain ranges, deserts, and entire climate zones, both quietly holding onto the same lost branch of humanity for well over 100,000 years each. Which raises a question I think deserves its own space entirely, rather than a rushed mention squeezed in at the end of an already long night. How exactly does a human body learn to handle air that thin at that altitude well enough to raise children there for well over 100,000 years? Because as it turns out, the Denisovans did not just endure that mountain air. They may have quietly handed down the exact biological trick for surviving it to people who are still breathing it in right now at this very moment high above the clouds. Let me tell you about a small stretch of genetic material tucked away on one of your chromosomes that most people will go their entire lives without ever hearing about. Scientists gave it a rather dry technical name, something along the lines of endothelial PAS domain protein 1, which is exactly the sort of phrase that makes eyes glaze over in a lecture hall. So let's not use that name again tonight. Let's just call it the altitude gene, because that is quite plainly what it actually does. Every human body carries some version of this particular gene, and its basic job is to act like a kind of internal referee for oxygen. Deep inside your cells, there are molecular sensors constantly checking how much oxygen is actually available, and when the air around you gets thin, when there is simply less oxygen available in every single breath you take, this gene helps decide exactly how your body should respond to that shortage. Think of it as a quiet, ever-present emergency dispatcher, deciding whether the situation calls for a full response or whether things are for now still manageable. Here is where it gets interesting and honestly a little counterintuitive. Most of us would assume the correct response to thin air is simple. Make more red blood cells. More red blood cells means more oxygen carried through your bloodstream, which sounds like exactly what a struggling body would need in a pinch. And in the short term, that assumption is more or less correct. Spend a week or two visiting somewhere high in the mountains, and your body will start doing precisely that, cranking up red blood cell production to compensate for the thinner air around you. It is a perfectly sensible emergency response, the kind of thing your body has clearly practiced for a very long time. The trouble is, what happens if you never leave? If an entire population tries to settle permanently at extreme altitude generation after generation, that same emergency response stops being helpful and slowly starts becoming a serious liability instead. Blood that carries too many red blood cells gets noticeably thicker, more sluggish, harder for the heart to push through narrow blood vessels. Over years, that thickened blood raises the risk of dangerous clots, strains the heart, and in pregnant women, it can seriously threaten both mother and child. Populations who settle at extreme altitude and simply keep doing what their bodies naturally want to do often end up dealing with something doctors call chronic mountain sickness, a slow, grinding condition that quietly shortens lives over time. So here is the puzzle that quietly sat in front of researchers studying the Tibetan Plateau for years, refusing to fully resolve itself no matter how carefully they looked at it. People have been living at extreme altitude there for a very long stretch of human history, seemingly without the same widespread health crisis you might expect from everything I just described. Their blood, when tested, does not thicken up nearly as dramatically as a lowlander's blood would under the exact same conditions. Somehow their bodies had found a smarter, gentler way to cope with thin air, one that avoided the worst long-term costs almost entirely, generation after generation, without anyone fully understanding why for a very long time. It was the kind of quiet mystery that sits in the background of a scientific field for years, acknowledged by everyone, solved by no one, until the right tools and the right question finally arrive at the same moment. When researchers finally traced the genetic root of that difference back in 2014, they found it sitting right inside that altitude gene we started with tonight. Tibetans carry a distinctive version of it, one that keeps their red blood cell production more restrained at high altitude, protecting them from the thickened blood and its dangerous consequences, while their bodies still manage to function remarkably well on far less oxygen than most of us would ever cope with comfortably. Then came the truly startling part, the moment that turned a tidy piece of medical genetics into something far stranger. When scientists compared this particular Tibetan version of the gene against a wide library of reference genetic material, hunting for where it might have originally come from, it did not closely match other modern human populations scattered across the globe. It did not particularly match Neanderthals either. It matched Denisovans, almost precisely as though someone had traced directly back to a single specific source. Sit with that for a second, because I think it deserves a proper pause before we move on. An extinct population one we have spent this entire night piecing back together from broken bone fragments and forgotten fossils, apparently left behind a working biological survival manual tucked quietly inside the genetic material of people living on that same high plateau today. Not a vague resemblance, not folklore dressed up as science. An actual traceable physical inheritance still doing its job more than 100,000 years after the population that originally built it seems to have vanished from the fossil record entirely. Scientists have a specific term for this kind of event, by the way, one worth knowing because it comes up constantly once you start paying attention to human evolution. They call it adaptive introgression, which is really just a formal way of describing something rather beautiful in plain language. A population inherits a small piece of genetic material from an entirely different group, usually through interbreeding many generations earlier, and that particular piece happens to be so useful for surviving a specific environment that natural selection grabs hold of it and spreads it rapidly through the population generation after generation until it becomes common, even ordinary. This particular altitude gene has become something of a textbook example, cited constantly in genetics courses around the world, precisely because the evidence behind it is so unusually clear and complete. Most examples of ancient interbreeding leave behind messy, ambiguous traces, arguments in academic journals about whether a pattern really means what researchers hope it means. This one does not leave much room for argument at all. The match between the Tibetan version of the gene and the Denisovan version is precise enough that most researchers in the field consider the question essentially settled. Here is the detail I personally find the most moving part of this entire chapter, though. The genetic material itself appears to have entered the ancestors of modern Tibetans a very long time before it actually became useful to them, tens of thousands of years earlier, quietly sitting there in the population's shared genetic material, doing very little, neither helping nor hurting anyone in any obvious way. It was only much later, once their ancestors actually began settling permanently at serious altitude themselves, that this particular inheritance suddenly mattered enormously, and natural selection began favouring it aggressively, spreading it through the population at remarkable speed once it was finally needed. Think about that shape for a moment. A tool quietly inherited, carried forward through countless generations who had no particular need for it, waiting patiently until the exact right circumstances finally arrived to make it indispensable. It is a little like discovering your grandmother left you a set of thick, expertly stitched winter gloves decades ago. Gloves you never once needed while comfortably settled somewhere warm, right up until the day you finally moved somewhere brutally cold, and suddenly understood exactly why she had insisted you hold on to them all along, long after it seemed to make any sense. And this is not some isolated curiosity limited to one single village either. Researchers studying dozens of communities scattered across the Himalayas throughout Nepal and Bhutan found that the frequency of this Denisovan, derived version of the gene tracks remarkably closely with the actual altitude each community lives at, village by village, valley by valley. The higher a village sits, the more likely its residents are to carry this particular inheritance. Statisticians measured the strength of that relationship across more than 1,000 people, and found a correlation so strong it left very little room for coincidence. This is not folklore passed down over a campfire. This is measurable, repeatable, and remarkably consistent across an enormous stretch of mountainous terrain. Now let me bring this down from statistics into something you can actually picture, because I think it deserves a face, not just a graph on a research paper. In 1953, a mountaineer named Tenzing Norgay, alongside Edmund Hillary, became the first confirmed climbers to reach the summit of Mount Everest, the highest point on the entire planet. The achievement made global headlines within hours, celebrated as one of the great triumphs of human endurance and willpower. Tenzing was Sherpa, part of a Himalayan population, with deep ancestral roots stretching back tens of thousands of years on the Tibetan plateau. Sherpas have long been recognized both by mountaineers and by physiologists studying human performance as remarkably well suited to extreme altitude work, capable of exertion at heights that leave most visiting climbers gasping and struggling simply to stand still, let alone carry supplies uphill. Ask most people what made Tenzing Norgay's achievement possible, and you will likely hear about training courage and sheer physical toughness, all of which certainly played their part. Rarely does anyone mention the quiet possibility that part of the answer was already written into his body before he ever laced up a single boot, passed down from a population that vanished tens of thousands of years before he was born. Researchers studying Sherpa physiology found something rather striking when they measured a hormone called erythropoietin, the chemical signal your body sends out to trigger more red blood cell production once oxygen runs low. At an altitude of roughly 3,400 meters, the level of that hormone in Sherpa, blood looked almost identical to what you would expect from someone standing at only 1,300 meters, barely more than a modest hill by comparison. Their bodies, in other words, were reading the mountain air as far less threatening than it actually was, quietly declining to trigger the very same overreaction that tends to cause so much trouble for outsiders attempting to settle at that height permanently. Every time you hear about a Sherpa guide calmly carrying heavy supplies up toward Everest Base Camp, moving at a steady pace that leaves paying clients doubled over, gasping for breath 100 meters behind, there is a reasonable chance that same quiet biological inheritance borrowed from a vanished cousin, species tens of thousands of years ago, is doing at least part of that work invisibly in the background, Have you ever accomplished something and later discovered the real reason you found it easier than everyone around you had nothing to do with effort at all? I imagine most of us assume our advantages come purely from practice or willpower. Sometimes it turns out they were quietly written into us long before we were even born by people we will never meet and never properly know anything about. I want to give you one more piece of this puzzle before we move on because it makes the whole picture even richer, and I think it is worth the extra few minutes. Tibetans are not the only people on Earth who have learned to survive successfully at extreme altitude. On the opposite side of the planet, high in the Andes Mountains of South America, entire populations have thrived at similarly punishing elevations for thousands of years as well. But their bodies solved the exact same problem in a completely different way, without any help from a borrowed Denisovan gene at all. Andean populations generally do produce noticeably more red blood cells at altitude, closer to the expected response we would all assume made sense, but their bodies appear to have evolved separate genetic adjustments elsewhere to manage the downsides of that thicker blood, avoiding the worst complications through an entirely independent evolutionary path built from scratch, with no ancient cousin species handing them a shortcut. I find that comparison quietly fascinating if I am honest with you. Two completely different human populations on opposite sides of the planet, facing the exact same brutal environmental challenge, arriving at two entirely different biological solutions, neither one borrowed from the other. One group solved it by quietly accepting a genetic gift from an extinct relative who had already done the hard work over 100,000 years earlier. The other solved it entirely on their own, from scratch through their own long independent trial and error stretched across thousands of years. Evolution, it turns out, rarely insists on only one correct answer to a difficult question, even when the question itself is identical. So here is where tonight's particular thread comes to rest, at least for now. A population we have spent hours getting to know only through broken bone fragments, ancient teeth and faint traces of protein and genetic material, managed to leave behind something far more intimate than any fossil ever could. A working piece of themselves still quietly protecting the lungs and hearts of people, breathing thin mountain air on that exact same plateau, right now, this very evening, while you lie somewhere far away listening to their story unfold. We have followed the Denisovans from the freezing forests of Siberia, all the way up to the roof of the world, tracing a story that has taken us through laboratories, sacred caves, and now quietly into the very blood of people alive today. But their reach, as it turns out, did not stop climbing upward. It also stretched in an entirely different direction toward warmth instead of cold, toward air, thick with moisture instead of thin and dry, into a part of the world you would probably never expect an Ice Age population to have set foot in at all. Picture for a moment the exact opposite of everything we've explored so far tonight. Instead of pine forests and frozen rivers, imagine thick tangled green stretching in every direction, vines pressing against ancient stone, the air itself feeling almost solid with moisture. Instead of thin biting mountain air, imagine heavy humid warmth pressing against your skin from the moment you step outside, the constant hum of insect rain that seems to fall on its own private schedule, regardless of what anyone nearby happens to be doing. Northern Laos, tucked into the Altai Mountains of Southeast Asia, could not feel further from the icy forests of Siberia if it tried its absolute hardest. And yet in 2018, an international team of researchers working in this exact landscape climbed into a limestone cave that would eventually earn itself the nickname Cobra Cave. I have looked, and I cannot tell you with certainty exactly why that particular name stuck. Perhaps something about the shape of the rock formations inside. Perhaps a startled encounter with an actual snake nobody wrote down properly for posterity. The research papers frustratingly stay quiet on that particular detail, so I will leave the origin story to your imagination tonight the way any good bedtime tale probably should. The excavation itself had actually begun years earlier, part of a much longer effort exploring caves throughout this same mountain range, looking for any trace of ancient human presence in a part of the world that had for a long time remained something of a blank space on the map of early human history. Southeast Asia has never gotten the same attention in this particular field that Europe or East Africa traditionally received, partly because the hot, wet climate here tends to be so much less forgiving toward anything organic left buried in the ground. Most of what turns up during this kind of work is exactly what you would expect. Animal bone, broken stone tools if you're lucky, long stretches of nothing at all season after season, cave after cave, year after patient unglamorous year. What they found inside this particular cave, buried in ancient cemented sediment, alongside the bones of massive extinct elephant relatives called stegodons, alongside tapirs, deer and wild cattle, was a single tooth. A molar still lodged exactly where it had settled after who knows how many thousands of years of gentle undisturbed burial. Picture the scene for a moment. Researchers working carefully with small tools in the dim, still air of a limestone cave, brushing away sediment that had not been touched since long before anything resembling written history existed anywhere on the planet, surrounded by the fossilized remains of animals whose living descendants, if they have any at all, look nothing like the creatures preserved in that same layer of stone. The researcher who eventually led the study, Laura Shackelford, has described her team's first reaction rather plainly. It looked human in a general sense, the kind of shape you would recognize immediately as belonging to some sort of person, rather than an animal. But something about it felt off in ways that were hard to immediately explain. It was noticeably larger than you would expect from a typical modern molar. The enamel, the hard outer layer protecting the tooth, was distributed unevenly compared to anything the team had seen before, thicker in places that did not quite match the pattern anyone on that team recognized from their years of training and fieldwork. There is a particular kind of unease, I imagine, that comes from holding something you can tell almost instantly does not belong to any category you already understand. They knew almost immediately that they were looking at something unusual. What they did not know yet was exactly what. Dating a single tooth found deep inside a tropical cave turns out to be its own particular puzzle, one that required combining several different techniques we've already touched on tonight this time, working together rather than separately cross-checking one against another until the results either agreed or fell apart under scrutiny. Researchers measured the last exposure to sunlight locked inside grains of sediment surrounding the fossil. They measured the slow, steady decay of uranium trapped inside a mineral layer that had formed directly above where the tooth was resting, essentially sealing it in like a lid quietly closing over a jar across thousands of years. And they cross-checked both results against similar dating performed on nearby animal teeth found in that exact same layer. 3 separate lines of evidence built from 3 entirely separate physical processes, all quietly agreeing with one another. The tooth they determined was somewhere between 131,000 and 164,000 years old. Now here is where the story runs into the exact same wall we ran into earlier tonight up on that cold Tibetan plateau, except this time the obstacle is heat rather than cold. Genetic material simply does not survive well in a hot, humid tropical environment, not for anywhere near this length of time. Warmth and moisture are in a very real sense the natural enemies of ancient genetic material, breaking it down far faster than the freezing stillness of a Siberian cave ever would. I think it is worth pausing on that pattern for a second because tonight has quietly turned into a small tour of exactly how different environments treat evidence in wildly different ways. Cold-dry Siberia preserved genetic material well enough to identify an entirely new population from a single finger bone. The high-dry Tibetan cave destroyed that genetic material almost completely, but somehow left behind just enough protein to still tell a story. This tropical cave, warmer and wetter than either of those places, pushes preservation to its absolute limit. Every single environment writes its own version of the same evidence in a different fading language, and researchers have had to learn a slightly different way of listening in each and every location. So once again, scientists had to turn to that hardier, more stubborn kind of evidence, ancient protein sequences still faintly clinging to life inside the tooth structure, long after any usable genetic material had completely disappeared. When they compared the protein signature and the overall shape of the tooth itself against the jawbone recovered from that Tibetan cave, we spent time inside earlier tonight. The resemblance was striking. Similar enamel structure, similar internal proportions. A convincing enough match that researchers felt confident attributing this Southeast Asian tooth to the same broad population, or one very closely related to it. Denisovans, or their near relatives, it seemed, had also been living here in the warm, wet heart of tropical Southeast Asia. I want you to really sit with the geography of that claim for a moment, because I think it is easy to let a sentence like that slide past without registering just how enormous a range we are actually describing. Tonight alone we have followed this single, quietly remarkable population from the frozen pine forests of southern Siberia up onto the oxygen-starved heights of the Tibetan Plateau, and now down into humid tropical rainforest fringe territory in what is now Laos. That is not a modest neighbourhood. That is a stretch of the map covering nearly every major climate extreme our planet has to offer, from bitter sub-zero winters to thin mountain air to thick dripping jungle heat, all apparently mastered by descendants of the same ancient lineage. Have you ever tried to imagine your own extended family scattered across wildly different corners of the world, each branch adapting completely to wherever they happen to land cousins you have never met, building entirely different lives in entirely different climates? I think most of us assume that kind of dramatic environmental range belongs only to our own species, to modern humans, and our famously restless habit of spreading into every corner of the globe. The Denisovans, it turns out, may have quietly pulled off something remarkably similar tens of thousands of years earlier, without a single written record, a single monument, or a single person alive today who remembers their name for what it actually was. There is a wonderful, more detailed layer to this discovery too, one that goes beyond simply confirming Denisovans were physically present in the tropics. Researchers studying the chemistry preserved in animal remains from that same cave floor were able to reconstruct something rather specific about local diet and habitat, using techniques that measure faint chemical signatures locked inside old teeth, and bone signatures that shift depending on exactly what kind of plants and landscape an animal fed on throughout its life. Even though thick rainforest canopy sat not far away, the evidence suggests this particular individual was mostly feeding in more open woodland and grassland environments, rather than deep inside the densest jungle itself. I find that detail quietly fascinating, honestly. It would have been easy to assume that arriving in a tropical region meant fully adapting to a lush enclosed rainforest lifestyle, disappearing entirely into the canopy the way we so often picture ancient tropical life. Instead, the evidence hints at something more selective, almost strategic. This population appears to have sought out a particular kind of landscape within that broader tropical world, open enough to move through easily, to track game, to see clearly, rather than committing fully to the darkest, densest parts of the jungle pressing in nearby. It suggests a population making deliberate choices about where exactly to settle, even within an already unfamiliar new environment, rather than simply existing wherever they happen to end up. Does that sound familiar to you at all? In a smaller, more ordinary way, most of us moving somewhere new do not simply accept the very first available option either. We look for the neighbourhood that feels right, the particular corner of an unfamiliar city that somehow suits us better than the rest. Perhaps that instinct to keep searching for the right specific spot rather than settling anywhere at all is older than any of us ever gave it credit for being. Not far from this same cave, researchers have also found fossils belonging to early members of our own species, dated to somewhere between 70 and 86,000 years ago, at a nearby site called Tam Pa Ling, which means this small corner of the Altai Mountains, much like that cave floor back in the Altai Mountains we spent so much of tonight exploring, appears to have quietly hosted more than one kind of human, across an enormous stretch of time, each arriving, adapting and eventually moving on or disappearing long before the other ever showed up to take their place. I should be honest with you about something here too, because I think it matters, and because I promised at the very start of tonight to treat this history with real care, rather than dressing it up as more certain than it actually is. Unlike some of the fossils we discussed earlier tonight, this particular tooth has not yet been confirmed through genetic material, the way the very first Siberian discoveries eventually were. Researchers outside the original study, including respected voices in the field, like Chris Stringer at London's Natural History Museum, have been careful to note that further work is still needed before the identification can be considered completely settled beyond any doubt. The protein evidence and the shape of the tooth both point strongly in the same direction. But strong evidence in good science is not quite the same thing as absolute proof, and the honest, careful researchers behind this discovery would likely be the first to tell you that themselves. I actually find that honesty reassuring rather than disappointing. A field willing to say plainly we are fairly confident but not entirely certain yet is a field you can trust a great deal more than one that rushes to declare victory over every single new find just to make a bigger headline. Real science tends to sound a little more careful, a little more hedged than the confident, tidy headlines built around it afterward. Either way, confirmed beyond all doubt or not, this single tooth quietly reshaped how researchers think about where this ancient population actually lived. Not a small, isolated pocket tucked away in one cold corner of Siberia. A population that appears to have stretched itself generation after generation, migration after migration across some of the most dramatically different environments on the entire planet, adapting each time in ways we are still only beginning to properly understand. We started tonight with a single bone the size of a pea. We have since followed its owners across an entire continent through forests, mountains, and now tropical jungle fringe. And in every single one of these stories, one detail keeps quietly repeating itself, almost teasingly. Every piece of evidence so far has come from fragments. A finger, a jawbone, a tooth. Small broken pieces of a much larger picture we have never actually been allowed to see all at once. We have learned an enormous amount about where these people lived, how they moved, who they occasionally fell in love with, and what their bodies could endure. And yet after everything, we still could not have told you with any real confidence what a single one of them actually looked like standing in front of us. That is about to change. Because somewhere sitting quietly hidden for nearly a full century before anyone understood what they were actually looking at is something none of tonight's other discoveries have offered us yet. An entire face. 1933. A bridge under construction spanning a river near the city of Harbin in the far northeast of China. Ordinary physical work, the kind that fills most of history without anyone bothering to write it down. Men digging, hauling stone, laying foundations day after day, in a region that at that particular moment sat under difficult and dangerous foreign occupation, a time when almost anything valuable that surfaced could be seized without warning, and almost anyone could find themselves in serious trouble for the wrong reason entirely. One of those workers digging where a support beam needed to go struck something that was clearly not stone, not soil, not anything he expected to find buried beneath a riverbank. A skull. Enormous, heavy, unmistakably old, unmistakably human in shape, and yet somehow wrong, in a way he could not have properly explained even if he had wanted to try. Picture the moment for yourself. Mud-caked hands pulling something impossibly large and strange out of the ground. Other workers gathering around, nobody entirely sure what they were looking at or what they should do next. Here is where this story takes a turn most fossil discoveries never take. He did not report it. He did not hand it over to the authorities running that occupied region, at the time understandably fearful of what might happen to an object like this if it landed in the wrong hands during a period when almost anything unusual invited suspicion, confiscation, or worse. So instead he did something quietly extraordinary. He wrapped it carefully, carried it home under cover, and lowered it into an old family well deep enough to stay hidden from anyone who might come looking, and simply left it there. For more than 80 years. I want you to sit with that decision for a moment because I think it deserves more than a passing mention. A single, frightened, resourceful man with no formal training in anything resembling paleontology made a judgment call in a moment of real danger that an object he barely understood was worth protecting rather than risking. He could not have known what it truly was. He almost certainly assumed he would never find out. And yet he chose preservation over convenient secrecy, over any personal gain it might have brought him. And then, as far as most records show, he simply lived out the rest of his life, without telling very many people at all, carrying the secret quietly, the way some people carry things they suspect matter more than they can properly explain. The skull sat down there in the dark, cool water of that well, decade after decade, through the remainder of a brutal war, through enormous political upheaval, through the entire second half of the 20th century, while the man who had hidden it grew old and the world around that quiet patch of riverbank changed almost beyond recognition. It was not until relatively recently, when his family finally retrieved it and eventually passed it along to researchers at Hebei University, that anyone outside that one family laid eyes on it at all. When scientists finally examined the skull properly, they realized almost immediately that they were looking at something extraordinary, nearly complete, missing only a small handful of pieces, dated to at least 146,000 years old. A massive, thick brow ridge sitting heavily above the eyes, the kind of feature that makes a face look almost carved from stone rather than grown from flesh. Square, deep-set eye sockets. A long, low, robust brain case, wide and imposing the kind of skull that would look entirely at home in an illustration of some ancient primitive brute. And yet, tucked inside all that heavy, ancient-looking architecture, a brain roughly the same size as yours or mine, if not slightly larger, a strangely uncomfortable combination for anyone still clinging to the old idea that ancient equals unintelligent. Strength and intelligence apparently were never actually opposites in the first place. This skull simply refused to let anyone keep pretending otherwise. In 2021, researchers formally announced the discovery to the world, giving it a name that practically guaranteed headlines. Dragon Man, drawn from the river and region where it had been found, formally proposed as an entirely new species, altogether separate from every other branch of the human family tree we have discussed tonight. The announcement caused a genuine stir, sparking real disagreement among paleontologists about whether this skull truly represented something brand new, or whether it belonged to a group science already knew just wearing a face nobody had properly seen before. Newspapers around the world ran the story with excitement, publishing striking reconstructions of what this supposed new species might have looked like walking the earth. Behind the headlines, though, a much quieter, much more careful argument was unfolding among the researchers actually qualified to weigh in an argument that would take years and an entirely new piece of technology to properly resolve. Have you ever looked at a familiar face and felt certain you recognized them, only to be told quite firmly that you were mistaken? That was more or less the position the entire scientific community found itself in for the next several years, staring at an undeniably real skull, arguing over what to actually call it. Here is where the story runs directly into a problem I think you will recognize by now, since it has quietly followed us through nearly every discovery tonight. To settle the question properly, researchers needed genetic material, and the single best place to find well-preserved, ancient genetic material inside a human skull is usually a small, extremely dense structure tucked deep inside the ear, called the petrous bone, a part of the skull so hard and so well protected by the rest of the head surrounding it that it often survives long after everything else around it has broken down completely. It is in a very real sense the vault inside the vault, the single most reliable place a geneticist can turn to when everything else has failed, except in this particular case that piece was missing. Whoever had originally excavated, cleaned or handled the skull at some point during its long, quiet journey through the 20th century had removed it, for reasons nobody today can fully explain, perhaps out of simple curiosity, perhaps by accident, perhaps for a reason lost entirely to time, along with almost everything else about the skull's early history. The one part of the skull most likely to hold clear answers simply was not there anymore, gone before anyone who might have understood its importance ever got the chance to protect it. For a long while that seemed like it might be the permanent end of the story, a magnificent, nearly complete skull, and no reliable way to confirm beyond argument and educated guesswork exactly what it actually was. Then, in 2025, a team led by a researcher named Xiaomei Fu decided to try something almost nobody expects to work particularly well. Rather than searching for genetic material inside bone, they turned to something most of us would rather not think about too closely right before falling asleep: dental calculus. The hardened plaque that slowly builds up along the base of anyone's teeth over a lifetime, mineralizing into something almost like a tiny stubborn shell, the kind your dentist scrapes away during a routine cleaning without a second thought. It turns out that unglamorous little shell can act as an accidental time capsule. As it hardens, it can trap and seal away tiny fragments of genetic material and protein, protecting them from the outside world for an extraordinarily long time, sometimes long after the rest of a skeleton has given up almost everything it once held. Researchers scraped away barely 1/3 of a milligram of that ancient material, an amount so small it is difficult to properly picture roughly the weight of a single grain of table salt, and got to work in exactly the kind of ultra-careful laboratory conditions we spent time inside together earlier tonight. Most of what they recovered, roughly 80% by some estimates, turned out to be modern contamination, stray genetic traces left behind by everyone who had touched, cleaned or examined the skull across the better part of a century, exactly the kind of quiet, patient contamination problem this entire field learned to take seriously the hard way generations ago. But buried inside that overwhelming static, a genuine signal survived. Ancient maternal genetic material, distinct, readable, and startlingly familiar. It matched Denisovans. Specifically, it lined up most closely with individuals from that same lineage who had lived somewhere between roughly 217,000 and 106,000 years ago, an early branch within the wider Denisovan family we've been tracing across an entire continent tonight, and in a separate study published at almost the exact same moment, an entirely different research approach reached the very same conclusion, this time analysing ancient protein sequences preserved deep inside the skull's remaining bone structure. The same broad family of technique we met earlier tonight in that jawbone from the Tibetan plateau. Two completely independent methods run by different teams using different pieces of evidence, arriving at the exact same answer within days of one another. Denisovan, researchers who had studied Denisovan material before, including a scientist named Frido Welker, whose work we touched on earlier tonight up on that cold mountain plateau, described the protein evidence as pointing overwhelmingly toward this identification with almost no realistic alternative left standing. Chris Stringer, whose careful, appropriately cautious voice we also heard from earlier tonight, called it likely the single most complete Denisovan fossil ever recovered. Not every single researcher in the field agreed instantly, and I think that honesty is worth including here rather than smoothing it over for the sake of a tidier story. A small number of scientists remained cautious, wanting still more evidence before fully retiring the idea of a separate species altogether. Science done properly rarely produces total unanimous agreement overnight, and I would trust this discovery a good deal less if it had. But for the overwhelming majority of researchers working in this field, the question had effectively been settled. This was not some entirely new branch of humanity nobody had ever encountered before. This was Denisovan, the most complete, the most striking, the most richly informative Denisovan specimen the world had ever seen hiding in plain sight inside a hardened riverside well for the better part of a century, protected quite unintentionally by a frightened man who could not possibly have known what he was truly saving. Think about everything that had to happen for you to be lying here right now hearing this particular sentence. A skull needed to survive 146,000 years underground before anyone ever dug near that riverbank at all. A frightened worker needed to choose secrecy over surrender protection, over convenience during one of the most dangerous periods of the entire 20th century. A family needed to hold on to that same secret for decades quietly, without fanfare, generation folding into generation. And finally, scientists needed to develop a technique clever enough to pull answers out of something as unglamorous as hardened tooth plaque, precisely because the one piece of bone that would have made the job easy had already mysteriously gone missing. Every single link in that long improbable chain could have failed. Any one of them breaking would have meant this face stayed buried literally and figuratively forever. We finally have a face for the people whose story we have spent this entire night piecing together from broken fragments. Massive brow ridges, a long heavy skull built for durability rather than delicacy. And underneath all of that formidable ancient-looking architecture, a brain every bit as large, quite possibly larger than the one currently processing every word of this sentence. I find myself wondering more than I probably should what that worker in 1933 actually thought, standing there with an enormous ancient skull in his hands, deciding in a moment of real fear that hiding it carefully was better than losing it entirely. He never got an answer to the question he must have quietly asked himself. What is this? Who was this? He simply trusted his own instinct that it mattered, and then he let that instinct carry the weight of the decision all on its own for the rest of his life without ever once knowing whether he had made the right call. Have you ever protected something you did not fully understand purely because some quiet part of you insisted it was worth protecting anyway? I suspect that instinct runs deeper in all of us than we usually give it credit for, and I suspect it has quietly saved more history than we will ever properly know about tucked away in wells attics and quiet family drawers all over the world. Now that we finally have a face, an unmistakably real physical complete face staring back at us across 146,000 years, I think it is worth asking an obvious question. If one overlooked, misidentified skull could sit quietly in museum storage and family memory for the better part of a century before anyone recognized what it truly was, how many other Denisovan fossils might already be sitting somewhere else entirely mislabeled, misunderstood, waiting patiently in a drawer or a display case for someone to finally take a second, more careful look? That question deserves an answer, and as it happens, one was already sitting in a museum drawer in Taiwan, waiting quietly for exactly the same kind of technology that finally cracked open the mystery of that riverside skull. If tonight has taught us anything so far, it is that the past does not always wait patiently in the ground for a shovel to arrive. Sometimes it has been sitting behind glass correctly labelled as old and correctly understood as anything more specific than that, for far longer than any of us would probably guess. This particular story does not begin in a laboratory or even on land. It begins somewhere out in the Penghu Channel, the stretch of water separating Taiwan from mainland China, where local fishermen have spent generations dragging heavy nets across the seafloor for their daily catch. Every so often, tangled in among the usual hauls, something else comes up. A stone tool, a fragment of bone worn smooth by decades underwater. Most of it gets tossed back without a second thought, mistaken for driftwood or simple rock, indistinguishable from the ordinary debris that collects on any ocean floor. Here is a piece of geography worth understanding before we go any further, because it explains something that would otherwise sound almost impossible. During the depths of past ice ages, an enormous amount of the planet's water was locked away in glaciers, and sea levels around the world dropped dramatically as a result by well over 100 meters in some places. The seafloor beneath that same channel was not always underwater at all. For long stretches of the deep past, it was simply dry land, a wide, low plain connecting what is now Taiwan to the Asian mainland, walked by animals, and it turns out walked by people too. When the ice eventually melted and the ocean rose again, that entire landscape quietly disappeared beneath the waves, taking whatever it held down with it. Fishing nets dragging along that same drowned ground today are essentially reaching back across tens of thousands of years every single time they touch bottom, hauling up pieces of a world that has not existed above water for longer than anyone can properly picture. Sometime before 2015, one of those nets pulled up a jawbone, thick, heavy, unmistakably old, with molars considerably larger and more robust than anything you would expect to see in a modern human mouth. Nobody recorded the exact circumstances in any real detail, the kind of small historical gap that tends to happen whenever an extraordinary find starts its life in the most ordinary possible way. It eventually made its way into the hands of a private collector, the kind of quiet, informal path so many important fossils apparently travel before anyone with the right expertise ever gets a proper look at them, before finally landing at Taiwan's National Museum of Natural Science, where researchers could finally study it properly, likely years or even decades after it first left the water. When scientists formally described the jawbone back in 2015, they knew immediately they were looking at something unusual, an archaic, heavily built mandible, unlike anything else previously found in that particular region. What they could not do, not with the tools available at the time, was confidently say exactly who it had belonged to. It joined a small, quietly frustrating shelf of fossils across East Asia that everyone agreed mattered enormously, and nobody could properly name. And here is where this particular story runs into a wrinkle that Denisova Cave, that Tibetan jawbone, even that riverside skull never had to deal with quite so severely. Every other fossil we have discussed tonight came from a cave buried inside identifiable layers of sediment that scientists could carefully date layer by layer, using the surrounding dirt itself as a kind of calendar. This jawbone came from the open sea floor, disturbed, dragged and displaced by fishing equipment, completely removed from whatever original layer of earth it had once rested inside. Without that surrounding context, pinning down a precise age became extraordinarily difficult, and honestly remains somewhat unresolved even now. Researchers have offered a fairly wide range of possible dates rather than one clean, confident number, and I think that honesty deserves real respect rather than impatience. For nearly a decade, that jawbone simply sat there on display, correctly recognized as ancient, correctly recognized as unusual, but stubbornly resistant to any more specific label. A genuine mystery hiding in plain sight inside a public museum, visible to anyone who walked past its display case on an ordinary afternoon, and yet essentially unreadable to the very people trained to study it. Then, in 2025, in the very same wave of research that finally identified that riverside skull we spent time with earlier tonight, a separate team turned their attention to this jawbone using the same family of technique, ancient protein analysis, carefully extracted from what little organic material still survived inside the bone, after so many thousands of years submerged in salt water, an environment that treats old proteins about as gently as you might expect. The proteins told a clear story, Denisovan. There was an additional, rather elegant detail buried inside that same analysis too. A particular protein linked to the Y chromosome, the piece of genetic material passed specifically from father to son, turned up in the sample, confirming that this particular individual had been male. It is a small thing perhaps, but I find it quietly moving all the same. Nearly 200,000 years after this person lived, and some unknown number of decades after his jaw was hauled up in a fishing net by someone who almost certainly had no idea what they were holding, science could still reach back across all of that distance and tell you with real confidence that you were looking at a man. I keep coming back to that fisherman, whoever he was, on whatever ordinary working day it happened to be. He was not searching for ancient history. He was almost certainly thinking about his catch, his schedule, whatever mundane concern fills an actual working day on actual open water. And somewhere in the middle of that ordinary shift, without any fanfare at all, he pulled up a direct physical connection to a vanished branch of humanity and simply moved on with his day, probably grumbling about having to untangle it from his net. Have you ever accomplished something remarkable without even realizing it in the moment, only to understand its true significance much later, sometimes years later? I imagine that fisherman, if he is even still alive today, has no idea the smallest, most forgettable moment of an ordinary shift ended up mattering this much to people he will never meet. Now, this jawbone is not the only puzzling fossil quietly waiting in an East Asian museum collection for the same kind of second look. There are others, and I think they deserve a proper introduction tonight because the picture forming around them is truly one of the most exciting open questions left in this entire field. In 1978, in Shanxi province, researchers uncovered a remarkably complete skull that came to be known simply by the name of the county where it turned up, the Dali skull. Roughly 200,000 years old, give or take, depending on which dating method you consult, it presented paleontologists with a face that stubbornly refused to fit neatly into any existing category. The brow was heavy, the face was broad, and yet certain proportions looked almost strikingly modern, in ways that unsettled researchers accustomed to tidier categories. A strange blend of features that seemed to belong to two different chapters of the human story at once, not quite matching older, more primitive Asian fossils, not quite matching the pattern expected of early modern humans either. For decades it sat in a kind of taxonomic limbo, acknowledged as important, debated endlessly at conferences and in academic journals, photographed from every conceivable angle, measured and remeasured by generation after generation of visiting researchers, and never fully resolved by anyone. 6 years later, in 1984, not far away in Liaoning province, researchers found something even rarer, a partial skeleton rather than just a skull nicknamed Jinyashan, after the site where it was recovered. Roughly 260,000 years old, this individual offered scientists something the isolated skull from Shanxi never could: actual clues about overall body size and build ribs limb fragments, pieces of a genuine physical body rather than just a face staring out from a display case. And just like its counterpart, it settled into that same frustrating middle ground, clearly significant, clearly ancient, clearly resistant to easy classification, no matter how many researchers took their turn trying. For decades, this entire cluster of Chinese Middle Pleistocene fossils sat in a rather uncomfortable holding pattern, within the field acknowledged by nearly everyone as important, argued over, constantly resolved by almost nobody. Some researchers lean toward calling them early, unusually developed members of our own species. Others suspected something else was going on entirely, without quite having the tools to prove it either way. It became something of a familiar, slightly exhausted joke in certain academic circles, an entire tangled cluster of fossils that stubbornly refused to sit still inside any tidy diagram, no matter how many careers were spent trying to force one onto them. Part of the trouble, if I am honest, came down to simple geography and timing. Much of the foundational work shaping how scientists classify ancient humans was originally built around fossils found in Europe and Africa, decades before this particular corner of Asia had been thoroughly explored at all. By the time researchers started uncovering skull after skull across China, carrying an unfamiliar mix of features that did not cleanly match any existing European template, the field simply did not have a ready-made box to put them in. Rather than force a poor fit, most serious researchers did the more honest thing, and simply admitted the fossils did not fit anywhere comfortably yet. Now, following the confirmed identification of both that riverside skull and this fisherman's jawbone, a growing number of researchers are looking back at fossils like Dali and Jinyashan with fresh eyes and fresh suspicion. Could these skulls sitting quietly in Chinese museum collections for decades already also turn out to belong to the same widespread Denisovan population we've been tracing across an entire continent tonight? I want to be careful and precise with you here because I think it matters more in this particular moment than almost anywhere else tonight. Nobody has confirmed this yet, not through genetic material, and not yet through protein analysis either. This remains for now an educated hypothesis, rather than a settled fact, a truly intriguing open question, actively being investigated by researchers who understand exactly how costly it is to guess wrong in this particular field. But given how recently 2 other long-standing mysteries from this exact region were finally cracked open, using tools that simply did not exist a decade earlier, I do not think it is unreasonable to expect more names added to this growing list before too many more years pass. Here is the pattern I want to leave you with before we move forward tonight, because I think it is the real quiet lesson buried inside this particular chapter. It would be easy to assume that after everything we have covered tonight, every major discovery worth making has already been made, and all that remains is waiting for the next lucky excavation somewhere remote and untouched. The truth, at least in this particular corner of science, looks rather different. Some of the most important discoveries left to make are not sitting undiscovered in the ground at all. They are sitting quietly in glass cases and storage drawers, already found, already labelled, already walked past by thousands of visitors a year, simply waiting for science to finally develop the vocabulary needed to properly understand them. I find that thought strangely encouraging, if I am honest with you. It means the next great discovery in this particular field might not require a single new excavation at all. It might simply require someone walking back into a familiar room, looking at something everyone has already seen 100 times, and finally asking the right question about it for the very first time. Progress in this case is not always about digging somewhere new. Sometimes it is about looking again more carefully at something that has been sitting right there the entire time. We started tonight with a story about a bone so small it was almost thrown away entirely. We are ending this particular thread with a reminder that entire skulls, entire skeletons have been sitting in plain sight for decades, patiently waiting their turn. It makes you wonder what else is out there right now, correctly preserved, correctly catalogued and still completely misunderstood, sitting a short walk away from thousands of visitors who have no idea what they're actually looking at. We have spent this whole night following fragments scattered across bone and stone, but there is one more place this story lives on somewhere far closer to home than any cave mountain or seabed we've visited so far tonight. It is not sitting in a museum at all. It is quietly sitting inside the bodies of people walking around right now in cities you have actually heard of, carrying pieces of this ancient population forward without ever knowing it. Let's follow that thread all the way to the present moment because I think it deserves exactly that. Not another cave, not another museum drawer. Somewhere far more immediate than either of those, somewhere breathing, walking, living an ordinary life completely unaware of what it is quietly carrying. If you happen to know someone from Papua New Guinea, from parts of Australia's Aboriginal communities, or from certain island nations scattered across the Pacific, there is a real chance that person is quietly carrying somewhere between 3 and 5% of their entire genetic makeup directly from Denisovans. Not a distant symbolic connection, an actual measurable, traceable piece of an extinct population's genetic material sitting inside their cells right now working, expressing itself quietly, doing its job the same way it has for tens of thousands of years, completely undetected by the person carrying it, invisible to the naked eye, invisible to any casual conversation, and yet perfectly real all the same. Sit with that percentage for a second, because on paper it sounds almost modest. 3 to 5% hardly sounds dramatic, the kind of number you might skim past in an article, without a second thought, easy to dismiss as a rounding error, next to everything else that makes a person who they are. But consider what that number is actually describing. Somewhere in the deep past, ancestors of these communities met Denisovans, and not just once, not just briefly. They formed relationships near enough, frequent enough to leave a permanent measurable fingerprint on an entire population's genetic material, one that has survived undiluted through hundreds of generations, all the way to someone scrolling through their phone on a bus in Port Moresby or Darwin this very evening, utterly unaware of the ancient story written quietly into their own biology, folded into every single cell without a single word of explanation attached. Here is a detail that truly surprised even the researchers who found it published only a few years ago, and I think it deserves far more attention than it usually gets. For a long time, Papuan and Aboriginal Australian populations were assumed to hold the record for the highest level of Denisovan ancestry found anywhere on Earth. Then a research team led by Maximilian Larina at Uppsala University in Sweden studied more than 1,000 people across 118 different ethnic groups throughout the Philippines, comparing their genetic material with painstaking care, and found something nobody fully expected going into the project. A community known as the Aita Magbukon, an indigenous group living on the Bataan Peninsula, turned out to carry even more Denisovan ancestry than anyone else ever recorded, somewhere between 30 and 40% higher than Papuan or Australian populations. If you account mathematically for more recent mixing with other regional populations that diluted the picture slightly, that gap grows even wider, still potentially closer to 46% higher once you strip that later layer away entirely. Why would one small community tucked away on a single Philippine peninsula end up carrying more of this ancient inheritance than anyone else on the planet? The most likely explanation is not that they interbred with Denisovans more intensely than anyone else did back in the deep past. It has more to do with what happened afterward over the tens of thousands of years since. Many populations across Southeast Asia and the Pacific later mixed extensively with waves of more recent migrants moving through the region. Migrants who themselves carried very little Denisovan ancestry, which gradually diluted the older inheritance further and further down through the generations. The way adding cup after cup of plain water eventually thins out even a strong cup of tea until barely any flavour remains. The Eta Magbukon, for reasons tied to their own particular history and relative geographic isolation, remained comparatively untouched by those later waves of mixing. They simply held on to more of the original inheritance undiluted for longer than almost anyone else studied so far. Does that pattern remind you of anything closer to home? I think about families sometimes in a similar way, the ones who move constantly blending into new communities every generation, and the ones who stay rooted in one place for a century or more, holding on to older habits, older recipes, older stories simply because nobody ever came along to gently dilute them with something newer. Neither approach is right or wrong. They just produce very different kinds of inheritance by the time they reach you. I find something quietly beautiful in that explanation, honestly. This is not really a story about one group being more connected to Denisovans than another, or somehow more special because of it. It is a story about which populations happened to stay more isolated afterward, and which ones ended up blending more freely with new arrivals over the following tens of thousands of years. Neither path is more or less valuable than the other. It simply means some communities kept a slightly clearer copy of a very old letter, while others folded new pages in on top of it. Generation after generation, each version equally real, equally human. Now, why does any of this show up so strongly in Oceania and the Philippines specifically, and barely register at all in Europe or most of mainland Asia? The honest answer connects directly back to the geography we spent time exploring earlier tonight. As early modern humans migrated out of Africa and moved through Southeast Asia, that same region we followed all the way to a tropical cave in Laos, some of those groups appear to have crossed paths with Denisovan populations living there, forming relationships, having children before continuing onward toward Australia and the islands of the Pacific Island, hopping across stretches of open water that would have demanded real courage and real ingenuity to cross at all. Populations who took other routes heading instead toward Europe or staying within mainland Asia largely did not have that same particular encounter, or had it in a much more limited, diluted way. The genetic map we see scattered across people alive today is essentially a fossilized record of ancient footpaths, written not in stone, but in the quiet architecture of human cells, readable by anyone with the right instruments and the patience to look closely enough. Every population carries, without knowing it, a kind of biological passport stamped by everywhere their ancestors actually passed through, long before passports or borders, or even the concept of separate nations existed anywhere on the planet. Let me shift from geography to something even more personal now, because there is a second layer to this inheritance that I think matters even more than the raw percentage itself. Researchers studying the genetic material of modern Papuans found that Denisovan-derived genetic segments do something rather specific inside the body. They cluster disproportionately around genes involved in the immune system, the network of cells and signals responsible for recognizing and fighting off disease. One gene in particular, called OAS1, plays an important role in your body's defense against viral infection, essentially helping cells recognize when a virus has broken in and triggering the alarm that shuts down its ability to copy itself before it can spread further. This particular gene shows clear signs of Denisovan ancestry in populations across Melanesia, a small inherited edge in an ongoing invisible war every human body fights constantly whether we ever notice it happening or not. Interestingly, when researchers compared this pattern against Neanderthal, derived genetic material in the very same individuals, the immune system connection simply was not there in the same way. Neanderthal ancestry seemed to influence other different aspects of biology entirely. Whatever advantage Denisovan ancestry offered here specifically around fighting disease appears to be something distinctly its own, a particular inherited talent belonging to one branch of the family and not automatically shared by the other. Think about what that actually means practically for a moment. When early modern humans first arrived in an entirely unfamiliar part of the world, they would have encountered diseases and local pathogens their bodies shaped by generations spent in Africa had never once faced before. New insects, new water sources, new proximity to unfamiliar animal populations, each one a potential doorway for illness their immune systems had no practice recognizing. Denisovans, on the other hand, had already been living in exactly these environments, adapting to exactly these local threats for well over 100,000 years by that point, generation after generation quietly refining a genetic defense system tuned specifically to this particular corner of the world, tested and proven long before any newcomer ever set foot nearby. When these two populations came together, whether through simple proximity or something closer, they were not just exchanging affection or curiosity. In a very real biological sense, they were exchanging survival tools, a kind of quiet, unintentional gift passed from a population who had already done the hard work of surviving a new land to newcomers who badly needed exactly that advantage and had no way of knowing it existed until it was already inside them, already working. We talked earlier tonight about a very similar story playing out at extreme altitude, a different gene entirely borrowed for a completely different purpose, helping certain populations breathe more easily in thin mountain air. This is the same underlying pattern showing up again in an entirely different part of the body for an entirely different reason. It makes me wonder just how many other quiet advantages scattered throughout the human genome we simply have not identified yet, each one another small unacknowledged gift passed down from a population most of us had never even heard of before tonight. Have you ever benefited from something you did not choose, did not earn, and did not even know you had, until years later when someone finally pointed it out to you? I think a surprising amount of human life works this way, quietly underneath the surface long before we ever notice. Here is a comparison worth sitting with too, because I think it sharpens the whole picture even further. Neanderthal genetic material shows up in small amounts, roughly 2% across nearly every non-African population on the planet, spread fairly evenly from Europe to East Asia to the Americas, a wide, gentle dusting rather than a concentrated deposit. Denisovan genetic material behaves completely differently. It barely registers at all in most of Europe. It is nearly invisible across much of mainland Asia. And then quite suddenly in Melanesia, in parts of the Philippines, in Aboriginal Australian communities, it surges to levels many times higher than anywhere else on the map. Two different extinct populations, two completely different patterns of inheritance, each one telling its own separate story about where ancient people actually walked, met, and occasionally fell in together. I want to leave you with one final thought before we bring tonight's story toward its end, because I think it is worth carrying with you as you finally drift off. Somewhere tonight in a city with a name you would recognize immediately, someone is sleeping the same way you're about to carrying inside every single cell of their body, a working, functioning piece of a population that vanished from the world so long ago that for most of human history nobody even suspected they had ever existed at all. They did not choose this inheritance. They did not earn it. They will likely never think about it consciously on any ordinary day of their life, going about their morning coffee, their commute, their small daily routines, with absolutely no sense of the weight quietly resting inside them. And yet it is there quietly protecting them, quietly connecting them backward across more than 100,000 years to people who once stood in a cold Siberian cave on a windswept Tibetan mountainside, in a warm tropical forest, never once imagining that any small part of themselves would still be walking around wide awake, so very far into an unimaginable future they could never have pictured in a world they would not recognize even slightly. I think that is worth sitting with for a moment before we wrap things up properly tonight. History books tend to treat extinction as a clean final ending, a door quietly shutting somewhere in the deep past never to open again. The Denisovan story we've spent all night piecing together suggests something gentler, and honestly something a little more hopeful. Extinction in the strictest biological sense absolutely happened. Nobody alive today is fully Denisovan, walking around exactly as they once did. But something of them clearly did not end at all. It simply folded itself quietly into the rest of us, scattered across specific corners of the world, waiting patiently for science to finally catch up and notice. It was there the whole time, patiently, without complaint, for over 100,000 years. We began this story with a single bone smaller than a pea, almost thrown away by accident. We are ending it somewhere far larger than any single fossil could ever be inside the living, breathing bodies of people who share this exact planet with you right now. And there is still one more piece of this puzzle left to wrap up properly the story of how we finally learned to see the whole shape of everything we have gathered here tonight and what it might actually mean for the rest of us going forward. Let's finally step back all the way back and look at the whole shape of what we've actually been building tonight, piece by careful piece, the way you might finally step away from a puzzle after hours spent hunched over it and see for the first time the entire picture, rather than just the one small section you happen to be holding in your own two hands. It started with something almost embarrassingly small. A fragment of bone barely the size of a pea, nearly overlooked entirely by tired hands, sorting through bucket after bucket of ordinary debris on a cold mountainside in Siberia. Nobody kneeling in that cave in 2008 had the faintest idea what they were actually holding. It travelled across 2 continents to a laboratory in Germany, into the hands of a scientist who had spent decades quietly learning the hard way exactly how easily this kind of work could go wrong, ever since a humbling lesson involving Egyptian mummies decades earlier in his own career. And from that single fragment came a name for an entire vanished branch of humanity, born not from a skeleton laid out on velvet in some grand museum hall, but from careful patient chemistry alone, performed by people who had learned exactly how not to fool themselves. From there, the story simply refused to stay small. We went back into that same cave and found it had never truly belonged to one population at all, but to 3, taking turns sometimes overlapping across roughly 300,000 years, leaving behind jewellery too sophisticated for anyone's tidy assumptions about ancient life, a bracelet drilled clean through solid stone by patient hands, with nothing but time and skill to spend. We traced a family tree that turned out not to be a tree at all, but something closer to a braided river splitting and rejoining itself across hundreds of thousands of years, carrying inside it an even older nameless population. We know only through a faint genetic echo, a language with no other surviving speakers remembered only because someone once borrowed a handful of its words. We met a 13-year-old girl, half Neanderthal, half Denisovan, the only direct proof ever found that 2 entirely different kinds of humans once fell in together closely enough to raise a child, her small broken bone somehow surviving 90,000 years, just so we could finally learn her family did not fit inside a single tidy category either. We climbed with this population all the way up onto the roof of the world to a sacred cave a monk once stumbled into by accident, while doing nothing more than praying, and discovered they had been quietly surviving air thin enough to leave most of us gasping generations before anyone else managed the same feat. We learned that surviving the air was not simply a matter of toughness or willpower, but of a specific quiet genetic trick borrowed from that same population and passed down unnoticed through thousands of years of ordinary family lines, who had no idea they were carrying anything unusual at all. We found a piece of that same survival, still tucked inside the blood of Sherpa mountaineers today, an inherited gift so precise it helped carry a man to the summit of the tallest mountain on earth, without him ever knowing exactly why his body handled the climb so differently from everyone standing beside him, gasping in the same thin air he somehow managed with something closer to ease. We followed this same population down into the humid heart of tropical Southeast Asia, discovering they had somehow mastered nearly every extreme climate this planet has to offer, from bitter Siberian winters to oxygen, starved mountain peaks to thick dripping jungle heat. A single ancient lineage stretched across almost every hostile environment imaginable. And then finally, after story, built entirely from broken fragments, we found a face, an entire skull hidden at the bottom of a well for more than 80 years by a frightened man who could not have known what he was protecting, waiting patiently through war and decades of silence until dental plaque of all things finally gave this vanished population back their features. We learned that Fossil was not alone either, that other puzzling skulls have likely been sitting quietly in plain sight in museums for decades, correctly preserved and completely misunderstood, simply waiting for science to catch up to what was already right there in front of it the entire time. And we ended appropriately, I think, not in a museum or a cave at all, but inside the bodies of people alive today, breathing, sleeping, walking through cities, with names you would instantly recognize, quietly carrying pieces of this ancient population forward, without a single conscious thought about it. Some of them protected from disease by a genetic gift passed down from parents to children across more than 1,000 centuries. That is the whole shape of it. Every piece we gathered tonight laid out together for the very first time side by side the way none of the individual researchers we met along the way ever quite got to see it themselves, each one holding only their own small corner of the same enormous puzzle. Now there is one more piece of this story I've been saving quietly for exactly this moment, because I think it deserves to sit right here at the very end rather than anywhere earlier. In the autumn of 2022, the Nobel Assembly in Sweden awarded its prize in physiology or medicine to the very same researcher whose career we followed earlier tonight, the young graduate student who once secretly tested Egyptian mummy tissue after hours convinced he had found something remarkable, only to later discover with real humility that he had mostly found his own contamination. Svante Pääbo received that award for what the official citation called his discoveries concerning the genomes of extinct hominins and human evolution work that ultimately gave rise to an entirely new scientific field, altogether now known as paleogenomics, the careful, patient art of reading genetic material out of the deep past. The prize committee specifically pointed to his sequencing of the Neanderthal genome, his discovery of Denisovans from almost nothing at all, and his demonstration that ancient interbreeding still shapes the health and biology of people alive today, the exact thread we spent the last part of tonight quietly following through modern lungs and modern immune systems. Think about the distance that man actually travelled across his own working life. From a nervous unofficial side project conducted late at night, hiding his real research interests from his own advisor, to standing on a stage in Stockholm decades later, honoured for reshaping how our entire species understands where it came from. His early failure did not disqualify him from that eventual outcome. In a very real sense, it built the careful, obsessive rigour that made everything afterward possible. I think that is worth remembering, whatever quiet failure you might be carrying around with you tonight, wondering if it disqualifies you from something you still hope for. Sometimes it is doing exactly the opposite quietly without your permission, whether you can see it yet or not, working in the background the way his own early mistakes clearly did for the better part of 2 decades. Here is what I keep coming back to now that we have finally laid the whole story out together. Most of us grow up picturing human history as something like a straight line. Simple ancestors slowly improving generation after generation in an orderly march toward exactly the kind of people we are today, each stage a small upgrade on the one before it. Tonight should have thoroughly dismantled that picture, and I hope it has gently the way a good story is supposed to challenge something without demanding you defend yourself against it. There was no straight line. There were several different kinds of humans sharing this planet at the very same time sometimes, for hundreds of thousands of years, side by side, crossing paths in caves, on mountainsides, in warm river valleys, occasionally falling in together closely enough to build a family. Some branches thrived for a while and eventually faded. Others quietly folded themselves into whoever came next, disappearing as a distinct population, while somehow never fully disappearing at all. What survived was never one clean, unbroken thread. It was always more like a braided river, the way we described it earlier tonight, currents splitting apart and rejoining, carrying old water forward into entirely new shapes nobody could have predicted from where any single drop first began its journey. I keep returning to that image, honestly, because I think it explains something about being human that most of us rarely stop to consider. We tend to want clean stories, a single origin, a single lineage we can point to and say, this is where I come from. Tonight suggests the real answer was always messier, and I would argue considerably more interesting than the tidy version most of us were handed as children. Nobody alive today descends from one single unbroken thread reaching cleanly back to the beginning. Every single one of us is the product of countless threads, crossing, tangling, occasionally breaking off entirely, and somehow still weaving themselves into something whole enough to carry forward into tonight, into this exact sentence, into you. You're one of those new shapes if you think about it. So is every single person you have ever met, ever loved, ever passed on a crowded street without a second glance. Every one of us is walking around as a kind of living confluence, carrying forward pieces of populations who never met each other, who spoke languages none of us will ever hear, who faced hardships. Most of us can barely picture from the comfort of a warm bed. All of it quietly folded together inside one ordinary human body breathing right now in your particular bed on this particular night, in a world none of the people we met tonight could have possibly imagined. Somewhere inside the story of nearly every person on this planet, whether the genetic trace is large or small, measurable or simply lost to time entirely, sits a version of the same quiet truth we spent tonight uncovering. None of us arrived here by a single tidy path. We're all in our own particular way the living result of countless small meetings across an almost unimaginable stretch of time, most of them utterly unremarkable in the moment they actually happened, and yet somehow together they built every single person listening to this sentence right now. Does that change anything about how you think of yourself even slightly? I do not expect a dramatic answer. I mostly just hope the question sits with you gently, the way a good thought is supposed to somewhere in the quiet space between wakefulness and sleep, without demanding anything more from you than a moment of honest attention before your mind wanders somewhere else entirely. I want to say something plainly before we wrap things up tonight, because I do not think I say it often enough. Thank you for staying with me through this entire story, from a single, overlooked bone all the way to a Nobel Prize ceremony decades later. Thank you for the patience it takes to sit with a story this long, this quiet, this willing to slow down instead of rushing toward easy answers. Stories like this one only really work with somebody willing to listen all the way to the end patiently, the way this entire field of science had to learn patience for itself. One small, hard-won discovery at a time, decade after decade, with no guarantee any of it would ever add up to something whole. If any part of tonight made you see your own body, your own history, or even just an ordinary museum display case a little differently, then this story has already done exactly what I hoped it would do. There are more stories like this one still waiting. Other bones, other caves, other quiet mysteries sitting patiently in drawers and mountainsides around the world, ready for someone curious enough to finally ask the right question about them. Some of them are probably sitting in a museum near you right now, mislabeled, misunderstood, waiting for their own moment, the way this particular story waited nearly a full century in places before science finally caught up to what had been there all along. I would love for you to be here again the next time we go looking for one of those stories together, whenever that particular night finds you, whatever corner of the world you happen to be listening from. For now, though, let the light stay low a little longer. Let your thoughts drift unhurried the way they are supposed to at this hour, following whatever quiet direction they naturally want to go. Somewhere inside you, quietly unnoticed, an ancient story is still being carried forward exactly the way it has been for longer than anyone can properly imagine, through cold caves and thin mountain air and warm tropical nights, not so different from wherever you happen to be resting your head tonight. You do not have to do anything with that thought tonight. You do not have to remember every name, every date, every fragment of bone we followed across this entire story. Just let it rest there beside you quietly, as your eyes finally drift shut, and let the rest of the night carry you the way it is supposed to. Sleep well,